All right. Well, greetings to the smartest people in America. You're about to get smarter because we're going to give you the answers to many unanswered questions in science. Like what caused the ice age? And how did the Colorado Plateau form? And how do you fuse past iron? That's a tough one. How do peanut-shaped asteroids form? And how did a mammoth freeze standing up with identifiable food in its stomach? And why did the Colorado River flow through a plateau instead of around it to form Grand Canyon? And these are all scientific mysteries and they can't answer. And I'll show you some of these quotes during the talk, or you can go into Grand Canyon's website. They admit they really don't have a way to explain it. But that's because their perspective of the past is wrong. And that's pretty much the key to this whole talk is who's got the better perspective of the past. And I believe the hydroplate has the best perspective. And that's why we're making accurate predictions and they're not. I'm Brian Lauer, and I'm going to be your host for the next few days. And it is with great joy and great excitement to welcome you to the world's very first Hydroplate Conference. And let that sink in for a little bit. In all of history, nobody's done what we're doing right now. There's never been a Hydroplate Conference, and you're sitting on the cutting edge of a scientific revolution. Once we're allowed to think outside those theories of blind chance and random collisions of atoms, I think we're going to be in the golden age of science. But we just have to wait for those archaic paradigms to fall. Okay, and they do need to be replaced. And we got some of the sharpest people in the country stepping up to the microphone. We got a professor of astronautics from the US Air Force Academy who's going to speak. Another one, we got a PhD electrical engineer in aerospace industry. We got someone who's a PhD in nuclear engineering and computational physics. We've also got someone who has a master's in aerospace engineering. And I was listing this off. I was at St. Cloud State talking to a student from Nepal. And when he heard PhDs, it's like, what can I get some more of these? Can I get some more of these flyers and invite my friends? So again, if you're zooming in, if you're one of the students at St. Cloud State, welcome aboard. I hope our paths cross in the future because I'd love to get this information on campus. And then we've also got someone who taught engineers about nuclear reactor plans and designs. We've got the co-hosts of Real Science Radio, which is my favorite website by far. When I'm driving around, I'm listening to Real Science Radio downloads and CDs. We've also got someone who led safaris both in South Africa and in the Western United States. So we got some of the sharpest people in the country to come here to help you understand the hydroplate theory. And I'm not one of those sharp people. I'm just the microphone. I tell people what the sharp people are saying. And I'm really excited to get this information out there. And we need to get it out there before NASA makes another colossal blunder based on bad assumptions because they have the wrong perspective of the past. So we have to get it out there. And I'm excited to do that. But I'm even more excited for you because I remember what it was like when I heard the hydroplate theory for the very first time. It was just changed my life. It was a pivotal point. I was listening to this one right here. We're listening to these the hydroplate theory CDs. You get these at Real Science Radio, rsr.org. This is only $20 and you get 6 CDs in there. And you learn about the mid-oceanic ridge and the origin of limestone and plateaus and Grand Canyon and comets and asteroids and frozen mammoths standing up. And you have all these seemingly unrelated topics, and yet they're all tied together with the hydroplate theory. So I encourage you to get that stuff, and maybe it's going to be a pivotal point in your life. And I believe it will be, but there are you need to give the hydroplate a chance. It's like when my kids were growing up, we'd play baseball at the park and we played fast pitch and I had the catching gear behind. And one time, the littlest kid out there, he went up to about the chests on the other guys. And he said, "Mr. Lauer, can I pitch?" And my knee-jerk reaction was say, "No, Grant, you can't pitch. You're too small. Get out back in the outfield. Let the big boys pitch." But I didn't say that. I don't like telling people what they can and can't do. It's like when I taught kayaking, occasionally you do the roll. When you go underneath, you can do a roll and get back up on top of the water without getting out. And occasionally someone would ask, "Well, can I do the roll without the paddle first?" And in my mind, I'm thinking that's almost impossible to do. I've only seen one person do it, and he was really good. But I don't give them any doubts. I don't put that doubt into them. Can I use it? You do it without the paddle? I say, sure, go ahead, because maybe they'll think of a way of doing it that nobody's ever thought of. And that's where the hydroplate theory is right now. Do a roll some revolutionary way. The hydroplate, I think, is going to revolutionize how we do science. Once we get the freedom to think outside that box that they put us in, and we'll get that. And we'll get to that. But there's a, this may be a pivotal point. Oh, yeah, going back to that baseball, Mr. Lauer, can I pitch? I didn't say no, and I didn't say yes, because that could have been a disaster. I said, I don't know, Grant, can you? Get on the mound, hit my glove. And he hit the glove 3 times in a row. Boom, boom, boom. I was stunned. It's like, yeah, Grant, you can pitch. Batter up, let's go. And so that's what I'm asking for you to do tonight, is to give the hydroplate a chance. Let the little guy pitch and see if he throws strikes. Because the big boy, NASA, just pitched a ball into the dugout. They were so off. And we'll get into that a little bit later. But for this to happen, to have a real good impact on your life, there's some obstacles that you're going to have to overcome. And let's talk about the elephant in the room, shall we? It's our government education system, where their whole view of the past, all they let you think about is blind chance and random collisions of atoms. And that really limits our thinking. And that's really hindering science. And so we got the wrong perspective of the past. And if we have the wrong perspective of the past, we're going to have the wrong perception in the present and the wrong focus on the future. And that's going to be devastating for everyone, as we're finding out. And so who else are the big boys? That's their same philosophy, blind chance and random collisions of atoms. There's NASA, National Geographic, Science, Nature, NOVA, museums, universities. These are all, they toe that same dogma, blind chance and random collisions of atoms. And it's not explaining things well at all. And it will fall apart. It's just a matter of time. And then I believe we're going to get the golden age of science. With this technology and the proper perspective of the past, it's going to be great. Okay. And so I encourage you, explore with open minds, not limited to theories of blind chance and random collisions of atoms, and think outside that government imposed box. Enjoy that freedom. Another obstacle might be institutional or organizational, company line. And academia is notorious for this. Jerry Bergman has 3 volumes out about people who did not toe the academic line and they were persecuted. Yeah, and that's really sad. Or maybe you're at an organization and they have a brand they want to push, or that they're pushing, and you have to push the brand. Even though there may be better ideas out there, you're at that organization, you want to stay there, you have to push the brand. And so with this conference, I encourage everybody to enjoy the freedom to think outside the intolerant dogmas of your institution or organization. And I think it'll be a pivotal point. If you do those 2 things, I think this will be a pivotal conference for your life. Okay, and let's talk about the conference schedule. You got the link for Thursday. You're gonna have to register for Friday and Saturday to get them links too. Okay, and we're gonna start. We're doing the intro talk tonight. We're gonna have Q&A at the end, and then Friday we're starting at 2 p.m. and that's Eastern time, 2 p.m. sharp. Each speaker has 40 minutes with a 10-minute Q&A, and then you got a 10-minute break before the next speaker. If the speaker goes, 45 minutes, then they have a 5-minute break for Q&A, but we're always going to end 10 minutes before the next talk so we can get the next speaker lined up, and so you can get up and walk around and get ready for the next one. And Friday, we're going from 2 to 6 with a movie at 6, and then take a break at 7. Then we'll have an 8 o'clock speaker. And then Saturday, this is a schedule change. We're starting at 11:45 because we want to show a video that's an hour long, and we didn't want to cut the beginning or the end. So we're starting it early, 11:45 a.m. Saturday. This is Eastern time. And then we're going to have speakers from 1 until 5 with Q&A at 6, take a break at 7, and then another speaker at 8. So that's the game plan. And it's like a smorgasbord. Eat as much, learn as much or as little as you want. And I'm going to say, if you can only have one meal or one speaker, I encourage you to check out the Comet talk with Kevin Lee on Saturday. I believe that will be the talk of this conference. And this conference is online, and there's a lot of benefits, and there's a few not so much benefits, hindrances. And some of the cons are we can't meet each other face to face. You don't meet, the crowd doesn't meet each other. You guys don't get to meet the speakers. And I really enjoy that part of it. And we can't do it with it being online. But, I've got an email out there. I'll give that to you in a little bit. And also, so we can, stay in touch. And then the benefits of this online conference, oh my goodness, low expenses. There's no airlines, no gas, no hotels, no restaurants. You don't have to take time away from your family. It's all right at your home, and it's very affordable. And if you want, you can make a donation. We're suggesting $20 a person, $10 a student. But if you don't, that's fine. We just want to get the information out there. And it's easy to share and invite others. It really is. And that's when I was talking to that student from Nepal. I said, yeah, you can share this with your friends in Nepal. And speaking of sharing, this is a video I'd like you to see. Let's see. Tell me when you can see this. This was a poster that we had hanging up at St. Cloud State. And so if people want to take a screenshot of that and share that on your social media, I would appreciate it because that poster got stolen. We had 3 of them up and now we got 2 of them up and they can't figure out who did it. So how do you fight censorship? Well, you share the information. So if everybody could just screenshot that, invite your friends, especially if you know people in another country. We want this to go all over the world. And again, we're going to answer those scientific problems. And and then I went to St. Cloud State and I went to all these different offices. I invited people, handed out these flyers that Ellen had printed up. And I told them about the conference and the physics and astronomy and biology, all those places. I went into their office and I said, we got a conference on Thursday online. And they were very receptive. Some of them asked for extra flyers. So they could put them in mailboxes. And that was so exciting. And I even went to the president's office and invited her. And she didn't have time for me. But then I went to this, had this table at the busiest door on campus. And I sat there and I'm working on my talk there. I typically did that. There's used to be 2 tables there. And that's what I would do. And I'd just have a sign. This sign said, do you like science? And I talked to some students who liked science and I told them about this online event. And then there was might have been a professor. He came by and he says, well, doesn't everybody like science? And I told him, you're going to love this conference. You know, this hydroplate, it explains 25 major features on Earth and in the solar system. Plus, it makes accurate predictions like what's in a comet. And if you can only see one talk, and I told him this too, you need to see the comet talk on Tuesday, where somebody stood face to face with a NASA scientist. And it's really interesting to see which one was right and which one was wrong. And I don't want to steal any thunder there. But then I went there yesterday to do the same thing. And what did St. Cloud State do? They took away the table. And so there, it's over time, it's getting harder and harder to get the truth out there. And so, you know, I'm the advisor for Grace Campus Fellowship. So if there's any students there who want the truth to come out, you want another perspective instead of being pigeonholed into thinking about blind chance and random collisions of atoms, feel free to email me or email Grace Campus at gracecampus@proton.me. That's gracecampus@proton.me. And one of the things I do is I help colleges start clubs so that the truth can prevail. I've started them at junior college, another private college. I almost had one going down in Virginia. And yeah, if you're watching this online and you want to make an impact in your college and you want some help, I'll do what I can to get there. Because I've given these talks from Minnesota to Florida and Pennsylvania to Colorado. And I just want to go where the truth needs to be told, and it needs to be told everywhere. Okay, and again, we need to register again. You know, go into hydroplate.org and click register for Friday and Saturday. It starts at 2 and at 11:45. Make sure you do that so you don't miss much of the smorgasbord. And I got this email. This one was rather interesting. Somebody had a best friend, and she always wanted intelligent Christian clients who would talk to them. And she said, your conversation with him has opened his mind. I believe he's been watching your videos a bit because he shared one with me. You know, I give these talks. I got a YouTube channel called Solidify Your Faith. And so I emailed her back and I said, well, you know, thanks for the encouraging words, but which video did he share with you? Because I give dinosaur talks and science talks and, you know, evolution talks or lies of evolution. And she said that he shared this talk with you. Uh-oh, what's happening? Okay. He said he shared this talk. And this was I had 20 minutes to speak at a Rotary Club. I could have told him anything. And I got him up to speed on the hydroplate. If you can imagine squeezing the hydroplate into 20 minutes, I did that. And this was during COVID, so the doors are open and there's a lot of background noise. And I tried to get rid of the background noise and the audio is just horrible. And yet this is the video that he shared with her. So the information overcame the bad audio. And in the beginning, that's Walt Brown's book. This is the 8th edition. That's what I got him up to speed on in 20 minutes. And you look at that book, you go into Amazon, that book's $280. And you used to buy it for $30 at Real Science Radio. And now it's 280. It's out of print. And that's the sign of a good book. Man, when books go out of print and go up in value, that's the good thing. Because I got bought a couple of science books at St. Cloud State. I figured I want to know what they're teaching the kids. And I went through them and then I went back to sell them back at the end of the semester. And they give me 10 bucks for one and zero for the other. And I thought, boy, that was a bad investment. But that's not the case with in the beginning, 280 bucks, because this has the proper perspective of the past. Oh, and there's also the 9th edition available online where I'm going to show you how you can download that. So that's worth the price of admission. And what I'm trying to do is change people's perspective. And it's easy to do, really. If you have enough information, that'll change people's perspective. Like, does anybody know what this is? Raise your hand. Well, that's, I don't see any hands. So that's because you weren't in senior math class in Ruthven, Minnesota, and 40 years ago. Mr. Wabeke, he drew this on the board, on the chalkboard, which shows you how old I am, a marker board. And he drew this on the board, and it's just a bunch of circles and lines, and it didn't make sense. And he said, that's a bear climbing up the other side of a tree. Raise your hand if you can see that. The bear climbing up the other side of a tree. Those circles are the paws, and the bear is blocking, or the tree is blocking the shape of the bear. So I put my artistic flair there. And so now my perspective of that has changed. Whenever I see that, I see a bear climbing up the other side of a tree. And again, our perspective is so important. I mentioned it before. If our perspective's bad, our perception will be wrong and our focus will be wrong. And NASA demonstrated that in spades. This is from August 9th, 2023, Science Times. And NASA accidentally causes Dimorphos boulder swarm as deadly as Hiroshima during DART mission. Yeah, so now we got this boulder storm coming up to us thanks to NASA, because they had their assumptions were wrong based on a bad perception of the past. And it said the large space rocks have the same speed as the targeted asteroid, so they are as dangerous. And it even had the unmitigated gall to say it had unforeseen implications. Unforeseen implications? Are you kidding me? Kevin Lee, and you're going to hear about this on Saturday, and he's going to be able to give you a personal account of this. He warned him 6 years ago. This is an email that he sent to Dr. Brownlee. Basically, he's saying, hey, if that rock is solid, it'll work, but if it's not solid, it'll fail if it's loosely held a rock pile, which is what this theory would say. It's a loosely held rock pile. And Dr. Brownlee didn't respond. And Kevin Lee, he's had phone conversations with him. And again, you're going to really want to see that again, it's 3 p.m. Eastern, the origin of comets. This is the one. Just cross it out on your calendar right now. That's 3 p.m. Eastern, 2 p.m. Central, 1 p.m. Mountain, and noon in the Pacific. This is, I believe, the best example of two opposing perspectives of the past. And one is clearly makes accurate prediction and the other one doesn't. So I encourage you, watch that. And by the way, Kevin Lee, he taught engineers at the nuclear engineering department at the Naval Shipyard. So he's no slouch. He understands this, and he's one of my favorite speakers. He really is. Okay, so now when I look at the Earth after seeing the hydroplate, I have another perspective. I don't have a perspective of blind chance and random collisions of atoms. No, I have a hydroplate perspective. And the hydroplate has a lot of answers. But if we don't know the questions, the answers won't mean anything. And so we're going to go through a bunch of questions. How do marine fossils get 5 miles above sea level on Mount Everest? I mean, that's a long way from the beach, am I right? And clams don't climb real well, right? But that's what we find up there. And what causes a mountain to rise so far, so high? And what's the mechanism? What's the energy? What's the force? And what formed the Mariana Trench, which is almost 7 miles deep? That's the deepest place on Earth. And what caused that? It's deeper than Mount Everest is high. And why are the trenches mainly in the Pacific Ocean? There's something different about the Pacific. Why is the Pacific so much different than the other oceans? Why does it have 40,000 volcanoes and the other oceans don't? And how did the mid-oceanic ridge form? I didn't even know about that till I started listening to those CDs. Yeah, it's a 46,000 mile mountain range that goes through the bottom of the oceans, and it circumnavigates itself and ends on itself. It's like, wow, that'd be one of the 8th wonders of the world, but it's buried in water, so nobody knows about it. How did that form? And why do the mountain ranges, why are they parallel to the mid-oceanic ridge? And why are there plateaus next to the major mountain ranges? That's a problem, because it's what mechanism would cause a large volume of low-standing continents to rise rapidly a mile in the air? And it says we have then a double-ended mystery. Remember those questions at the beginning? Those are a mystery when you don't have the proper perspective. For the Colorado Plateau, it seems to have grown downward at the same time that it emerged part rose upward. So it's a mystery. Okay, and what caused the inland seas to form? This is, this is like the Gulf of Mexico, the Mediterranean, the Black Sea, the Caspian Sea. These are places that have a lot of sand at the bottom. And we'll get into that. And how does a mountain range form? By stretching it in two directions. That's the mid-oceanic ridge. That's right. When you zoom in there, you see those are tension cracks. That's a rock that's getting pulled apart. And then when it gets too much pressure, it cracks and the pressure is released. So it's a straight crack, a tension crack. And as you notice, there's vertical and horizontal ones. So this thing was formed by stretching it in two directions. Well, how in the world do you do that? And how do you get the 90 East Ridge to form? This is 3,000 miles long and it points directly at the Himalayas. And where did all the sediment come from that averages a mile deep on the continents? Where did that come from? I always wondered that when I was a kid. Yeah, where did that sediment come from? And it's got an interesting ratio. It's 65 parts granite and 35 parts basalt if there's no carbon in it, like limestone. And why is it there more granite than a basalt? Very interesting. And what caused it to be so evenly mixed with a cementing agent like calcium carbonate there and quartz? Yeah, I mean, you can have all the sand you want on your driveway, but it's not turning into a cement driveway unless it's mixed with a cementing agent. And how do you get a cementing agent all over the world mixed really nicely, turning all that sediment into stone all over the world? Okay, and why are the layers so flat in Grand Canyon? Why aren't there erosion marks in there? And this one's a tough one. How do you get slanted layers under flat layers in the Grand Canyon? How in the world do you do that? Okay, and in Genesis history, that's a video. And when I spoke at a state college in Florida, I donated this to the library. And the librarian said, in the state college library, and he said, it's on the shelves. It's never on the shelf. People, they're just watching it over and over again. And it's really good. There's a couple issues I have with it, but it's really good. And this is a drawing of this Zuni mega sequence. And there's a bunch of other mega sequences underneath. You don't lay this down. They say, well, maybe there was millions of local floods. No, there isn't. No, there wasn't. This was all laid down at once. So it was at least a continent-wide flood. And then Dr. Tim Clary, he spoke at our Twin Cities Creation Science Association, and you can see his talk on YouTube. He's done a lot of research, and he says, you know what? These, these sediment layers, they're worldwide. They're not just on the continent. This is the same Zuni mega sequence. It's all over the world. How do you lay down worldwide layers of sedimentary rock? Okay, and how do you get canyons to form underneath the ocean? You know, most of the major rivers, they've got canyons under the sea. The Amazon, the Congo, that one's even longer than the Grand Canyon. Hudson and Ganges. How does that happen? And how does speaking of Grand Canyon, how does a little river cut a canyon 18 miles wide? You know, and where did the limestone come from? Because limestone, when it's produced, it also produces carbon dioxide. And there's 60,000 times more limestone than there is carbon dioxide in the atmosphere. And Walt Brown, he had a friend named, I think it was Bob Dietz, who coined the term seafloor spreading, if I'm right there. And he asked him, well, where'd all the limestone come from? And Bob says, beats the blank out of me. And so if you're interested in limestone, you can hear Ellen McHenry's talk at Friday at 5 p.m. Eastern, exploring the mysteries of limestone with HPT. That'll be very interesting. And Ellen, she's a science writer and independent researcher, and she's the one that pulled this all together. I am so proud of her. She was supposed to have help with all the webinar stuff, and somebody dropped the ball, and Ellen just picked it up and went charged forward. So you can thank all this for Ellen. Okay, and where'd all the dirt go? There was a Grand Canyon guide, I don't know, a long time ago, and he'd tell people as he's giving the guide, giving the tour, he says, you know what, I dug that. And a little kid said, well, where'd you put the dirt? And that question haunted him the rest of his life. Where did that dirt go? Yeah, and then why did the Colorado River flow through the plateau instead of around it? I mean, you look at the elevation thing, it'd have easily flown around the north and it would have flown around the south, but it didn't. It went right through the plateau. Why is that? And what causes the funnel and the barbed canyons? Okay, the funnel, you can kind of see it's narrow and then it spreads out as it goes to the southwest. But those barbed canyons are pointed pretty much to the north, those little canyons pointing more northward. That's because the land is slanted down going to the north. So that stuff is flowing to the north and hits the river. That big line going down, that's the river. So you got the land sloping to the northeast, and yet the river flows to the southwest. How does that happen? My brother-in-law was at St. Cloud State, and he took a geology class, and they tried to figure that out, and he said they could never find out that answer. That one was one that could never explain, and they don't have any good explanations for the Grand Canyon. Okay, and this potholes right there, they're on a 2,000-foot cliff. Now, potholes is when a rock gets caught in a vortex and it eats out the dirt there. And how do you get that on a 2,000-foot cliff, 3,300 feet above the river and 4 miles away from the river? Now, this is an anomaly, and theories should be able to explain the anomalies, and this theory does. But the blind chance and random collisions of atoms, that doesn't. And then how do you get this 5 to 10 ton rock raised into a sedimentary layer of rock? See that rock that's raised up into the sediment, and it came from that other rock down below. Yeah, that's not in the park website. I didn't see that at all, but this is an anomaly and it's in Grand Canyon. And your theory should be able to explain that. And again, hydroplate will. And how did Red Butte form? It's 1,000 feet of sediment capped with volcanic rock. And again, notice it's real close to Grand Canyon. And that's important. And what crushes granite? This is Gunnison Canyon, and we talked about the tension cracks in rocks. Those are straight. These aren't straight. These are compression rocks. And to put that in scale, those trees on the top, those are 15-foot trees. How in the world do you get that much force to crush that much rock? And we see the same thing in the bottom of Grand Canyon. In the inner gorge, the Vishnu schist looks just like that. That was crushed too. What force would do that? Okay, and how did mesas, buttes, and spires form? This is Monument Valley. And this is my second most popular talk on my YouTube channel, Solidify Your Faith. People are curious, how did they form? And how about petrified trees? How did they form? And about lineaments, how did lineaments, those are linear land features on Earth's surface, such as faults, how did that form? And how do you get a canyon under 2 kilometers of ice in Greenland? And in the other part of the South Pole, how do you get lakes under 2 miles of ice in Antarctica? This is Lake Vostok. It's under 2.5 miles of ice. And how do you get to a lake at all in Lake Vostok? Because this is the temperature graph. That bottom line is Lake Vostok. And that in the summer, they have their opposite. In January and February, or December and January, those are the peak year. That's their summer down there. It's 22 degrees below zero in their summer. And then in the winter, it's 85 degrees below zero. So how in the world would you get lakes with liquid water underneath 2 miles of ice? Something was different. And this textbook says South Pole is mostly covered by ice, but fossils show that crocodiles, dinosaurs, and palm trees once lived on that land. Well, maybe if it's warmer, you might get crocodiles, maybe dinosaurs. But how did palm trees live in darkness 4 months of the year? Palm trees, that's the tough one. That's a real tough one. And in the Arctic Circle, same thing. There's an island up there with permafrost, and you got snakes and tortoises and alligators and badgers and shrews, badgers who live in the ground. This is permafrost. How does that work? And they also have redwood trees. How are they going to live where it's dark 4 months of the year? And what froze the mammoths? Now, apparently there was like 500,000 tons of ivory that they took out of there. So there was a lot of mammoths there. So they need a lot of food, a lot of water. And there was one of them, how did a mammoth freeze standing up? They found it. It's in the museum, I think, in St. Petersburg. It was frozen standing up, and it still had identifiable food in its stomach. And again, mammoths are not Arctic animals. Let's get that straight. They call them woolly mammoths, but that's a misnomer. They don't have wool. They just have hair. And this hair doesn't have erector muscles or oil glands. They're not made to live in the Arctic. They would not survive a night there because they eat too much food, 300 pounds a day. They drink too much water. There's no way they're going to survive up there. But there was a lot of them up there. How in the world does that happen? And I mean, your nose gets cold in the winter. Just think if it was 6 feet long. That's a problem. That's a real problem. So how did it get so cold so fast during late summer? They could figure that out from the food in its stomach. And why didn't they thaw out? They're temperate animals. Yeah, maybe they froze, but why didn't they thaw out? And then what caused the ice age? There's 40 theories out there. It means there's none of them that work. And then look at why were there no glaciers in Alaska and parts of Siberia, which just boggles my mind. During the ice age, where there's snow down to Minnesota, you don't have glaciers in Alaska and parts of Siberia where there's permafrost. Boy, that's a mind bender right there. Okay, and how about deuterium? And why do comets have twice as much deuterium than the oceans? Because, deuterium is a heavy hydrogen. Hydrogen is proton and electron. Deuterium is a proton, electron, and a neutron. Where did all these neutrons come from? And if we got our oceans from the comets, they should have the same ratio, but they don't. The ocean is diluted by 50%. Why is that? And how do you fuse past iron? And I'm so glad we got somebody who knows that. Okay. And this is one of the greatest unanswered questions in physics. According to Discover magazine, it's number 3. How were the heavy elements from iron to uranium made? They don't know, but we'll explain it. Okay. And this guy says, this is from Science of 2002. We're all made of star stuff. The Big Bang created hydrogen, helium, and a little bit of lithium and other light atoms. But everything else, the carbon, oxygen, and almost 100 other elements that make up animals, plants, and Earth itself, was made by stars. The problem is that physicists aren't quite sure how stars did it. Why don't they put that in the general ed textbook? Why don't they put that in the grades or in the junior high textbook? They don't know how they did it. Yeah, they don't. They don't. And Glenn Collins, he spoke at our Twin Cities Creation Science Association too. You can see his talk on YouTube. He talks about he was in Ohio State, and he asked a bunch of physicists, what's the difference between science and science fiction? And nobody could answer it. See, for me, science is observable, testable, repeatable, falsifiable, the scientific method type of science. But those guys are working with the Big Bang and the Boltzmann brain and the multiverse, and those aren't testable. And Boltzmann brain, by the way, if you want to know how many straws they're grabbing at trying to figure out how we got here, he had Spike Passeris, as you go into creationastronomy.com. He's got 3 volumes out there. What you're not being taught about astronomy, and it just violates everything, breaks the big brains, whatever. But in the 3rd volume, it says what you're not being taught about the Big Bang and the universe, and it's more likely that a brain popped into existence than a universe popped into existence, and they call that the Boltzmann brain paradox or pulp problem or whatever. But again, check that out. Okay, and why do comets have stuff from the Earth? We've got water, salt, silicates, crystalline silicates, limestone, clay, which need water, cubonite, we'll talk about that, olivine, iron, organics, amino acid, bacteria, cellulose. They find that in comets, asteroids, meteors, interstellar dust. How in the world would that get up there? And again, that's why you need to listen to Saturday at 3 p.m. Eastern, 2 Central, 1 Mountain, noon on the Pacific, The Origin of Comets by Kevin Lee. He's going to explain that, how he knew what they'd find. But let's go back to this cubonite. It forms only in the presence of scalding hot water, 122 to almost 400 degrees. Well, what happens at water at 212 degrees? It turns into steam. Unless you're in Denver, then it's at 180 degrees. But yeah, and it goes, and according to all, how are you going to keep it, how are you going to keep it from turning into steam and get it that hot? That's a problem if you believe in blind chance and random collisions of atoms. That's a really, really, really big problem. Okay, according to all the standard explanations for comets, it is impossible to form liquid water inside a comet. Besides, liquid water cannot reach those extremely hot temperatures in a comet's low pressure environment. Indeed, even cold liquid water inside comets would instantly flash into steam because there's no pressure, leaving a remnant of ice. That's a big problem. Okay, and why does the atmosphere get ionized before earthquakes? And there's studies show statistically significant electromagnetic signal in days prior to the earthquakes. And also ants know what's going on too. In Germany, they got these big anthills and they all leave the nest. They leave the anthill when a day before the earthquake hits. They can sense it somehow. And I believe it has to do with electrical ionization. Okay, and why did Russians say they found sea plankton on the space shuttle? Allegedly discovered trace amounts of sea plankton and other microscopic organisms living on the outside of the station. Well, how would sea plankton get into outer space? How would that happen? How did rounded boulders get into Comet 67P? Because if something breaks apart in space, it's going to have jagged edges. The only way it gets to be rounded is if it's going through a fast flow of water. And we'll talk about that. Okay, how do asteroids get a moon? Get moons? I mean, because to catch a moon, it's almost impossible. They can't explain how Earth got its moon. They got 4 theories out there. None of them work. Because if you got 2 things coming at each other, they're either going to collide or they'll slingshot around each other. It takes something very, very, very special to create a moon. And I think it was Newton who said, we can explain the motions of the planets. We just can't explain how the motions began. And so, yeah, but anyhow. And if you think about if all you got is blind chance and random collisions of atoms, you won't be able to explain it either. Okay, asteroid Floyd, how did Florence get 2 moons? And this is according to Astronomy Essentials, Earth Sky. Okay, and peanut-shaped asteroids and comets. How in the world do peanut-shaped asteroids form? We talked about this at the beginning. It's a major mystery. Remember those questions at the beginning? Mystery. It's a major mystery how 2 objects, each to the size of skyscrapers, could collide without blowing each other to smithereens. This is especially puzzling in a region of the solar system where gravitational forces would normally involve collision speeds of 4,500 miles per hour. Yeah, that's a mystery, but not according to the hydroplate. We'll explain it. Okay, and how do chondrules form in space? And this is these are rocks that have been Z-pinched, for lack of rather. We'll get into that. How does that get into space? And why is the far side of the moon so much different than the near side? Did you know that? You know, the near side is full of that dark stuff. Those are lava flows, and there's hardly any on the far side. Why do you have all these lava flows and moonquakes on the near side, but not on the far side? And why is the far side 30 degrees colder than the near side? Why is that? Even if it's been there billions of years, it should be pretty much even. And why is the near side pounded and the far side peppered? Okay, and that's really counterintuitive because the Earth shields the near side. If there's anything coming in from the left, it's going to hit the Earth, not the moon. And then you throw in the Earth's gravity. Anything from the left, nearly all the way up and all the way down, is going to hit the Earth, not the moon. So it's real hard to get a direct shot on the moon, and yet it's the near side that's been pounded. Why not the far side? And why was the Earth's oldest rock found on the moon? Yeah, they went down, they bent down, and they picked up a rock, and it's from the moon. I bet there's Earth rocks all over the place up on the moon. And you'll understand why. And another question, they say found evidence that the rock was launched from Earth by a large impacting asteroid or comet. They don't know that. They don't know that at all. That's fiction. There was a rock. They don't know how it got up there. Okay, so you got to separate the facts from the fiction in these science journals. And I knew an instructor at a community college down in Virginia, and he said he always had his students have a journal, and whenever they got fuzzy words, they were supposed to write that in the journal. So then the kids knew when they were talking about science and fiction. And fuzzy words are like somehow, could have, probably, theorized. You get the idea. But why did NASA wait 50 years to release this information? That's interesting. And why do nearly all the short period comets go in the same direction as the Earth? Their theory says, hey, and our comets, our short-term comets, they should be gone in 10,000 years. They can do the computer programming, and Jupiter's going to sweep them all up in 10,000. Walt Brown says 12,000 years. Yeah, but we still have them now. So they say, well, if they couldn't have been there for billions of years, they must be repopulating themselves. So they came up with the Oort cloud. And if that was the case, it'd be a 50-50 mix. It wouldn't be 97-7 or 93-7, prograde versus retrograde. Okay, and why is Naiku orbiting backwards? Well, Naiku's weird orbit puzzles scientists. Well, that's because all they have to work with is blind chance and random collisions of atoms. Of course, it's going to puzzle them. This is space.com. Okay, and then this one from phys.org. Beyond Neptune, a chunk of ice is orbiting the sun in the wrong direction. The orbit of Naiku this is from a professor at the Harvard Smithsonian Center. The orbit of Naiku is unusual in that it's nearly perpendicular to the plane of the solar system. More than that, it's orbiting in the opposite direction of most solar system bodies. Furthermore, there are a few bodies that share the same orbital plane, with some orbiting prograde and some orbiting retrograde. That's the same direct orbit as the Earth and backwards orbit. That's prograde, retrograde. He says that was unexpected. Yeah, if your perspective of the past is wrong, but it fits perfectly with what we have. Okay, and then on Mars, how do you get canyons to form on Mars from water erosion? There's no liquid water on Mars. How do you get canyons that were formed from water erosion? All right, so we've asked a lot of questions. Okay, and so we want to change your perspective. Just like this picture, seemingly unrelated data points, circles, but then I told you, it's a bear climbing up the other side of the tree, and it fits, tied all those circles together. Well, guess what? There's a lot of unrelated data points here, and we're going to tie them all together with the hydroplate theory. And this is the 8th edition in the beginning, and prepare to get a proper perspective of the past. And it was put together by Dr. Walt Brown, a sharp guy. Went to West Point. He was an Army Ranger, paratrooper, got his PhD from MIT as a mechanical engineer in the heat transfer division. So he's really sharp. From MIT, really sharp. And then he was the director of the Benet Military Lab, where he had dozens of PhDs working for him and if not hundreds of scientists working for him. So he's rubbing shoulders with some pretty educated people. And he was the chief of science and technology studies at the Air War College. Just brilliant, brilliant guy. And he came up with this, and he's an engineer. So he's looking at what's happening at the Earth, and he's not looking at it what he was taught in geology school. He's looking at it from an engineering perspective. It's like, what force would cause that to happen, and how much energy would you need to have that, and what would the mechanism be? And it's just a breath of fresh air. And that's Walt on the left. That's Bob Enyart on the right. I think they were both national treasures. I believe Walt was today's Isaac Newton, and Bob Enyart was pretty close. I mean, yeah, it was, and he left stuff behind. Real Science Radio, rsr.org. He left it behind. What a treasure. Thank you so much, Bob Enyart and his family. Oh my. But then this guy, this is from the space station. An astronaut brought the In the Beginning book on DVD or CD, what an MP3, up in the space station. And he took a picture of it at the space station. And then he gave it to Bob, or gave it to Walt Brown. And he's a big fan. It seems like people who understand science really like this theory. And so he's a big fan. John, happy birthday again. He's a big fan. I'm a big fan. Okay, so now when I look at the Earth, I see hydroplate. That's what I see. Now, if I do my job right, that's what you'll see when I get through explaining this. Okay, and it's basically most theories go from effect. We know what the effect is, but we don't know what caused the effect. So we know we have going from an unknown to a known. That's what theories typically do. Well, this theory is different. Walt Brown, he sets up the cause with a theory, with one assumption. Basically, one assumption lets the laws of physics go through it, and then the effect is just matches perfectly with what we see. So it's a cause, which he knows, which is just one assumption. And Occam's razor, the simplest explanation, is probably right. Well, one assumption, and then the scientific, the currency for science is predictions, a whole bunch of predictions that are accurate. I think this one's right. And I went to St. Cloud State into their earth science department, and I met a professor, and I said, hey, you don't know, you don't have an accurate theory for Grand Canyon. And she knows that. Everybody knows that in that department. And I said, would you like to see a theory that works? And I held up the In the Beginning book. And then she said, to her credit, she said, yeah, I'd like to see that theory. And she had the book for about 6 months, and we got together for about an hour and a half and talked about it. And she said, if the assumption is true, the science works. I just don't believe the assumption is true. Okay, and what is that assumption? One assumption, that's it, just one assumption, is half of the ocean water was inside the Earth at one time. That's it. That's how it got there is not part of the theory, but that's the one assumption. Half of the ocean was inside the Earth, basically 60 miles down. Just think of the Earth as a big apple. And the crust is 60 miles thick, made of granite. And then you got a layer of water underneath that, about a mile thick. And then below that, you got basalt. Okay, 60 miles granite, a mile water, then basalt. And the granite and the basalt are touching each other at various places throughout the Earth. And so you got this huge subterranean water chamber. That's the only assumption. But if you want to know what it was like in the initial conditions of before the hydroplate, Ellen McHenry, she's going to talk tomorrow at 2, and she's going to explain what the initial conditions were. And then also Harold Gilbert's going to talk at 3, potential solution for formation of land during the creation week. So this is before the hydroplate happened. And Dr. Gilbert, he's got a Master of Science degree in aerospace engineering. Again, we got some really sharp people that you're going to be able to learn from. What a blessing that's going to be. But let's go back to this. Okay, you got the Earth. And back then, the crust. Okay, you got the one assumption. Half of the ocean's inside the Earth, 60 miles deep under the crust. Okay, and then the moon. Throw in the laws of physics now. The moon tugs on the Earth, the gravity, causes low tide and high tide twice a day. Well, it's also going to tug on that water inside the Earth, and it's going to stretch the crust forward and backwards. And back then, the Earth wasn't broken into plates like it is today. Oh, and by the way, plate tectonics don't work. There's problems with plate tectonics. And Fred Williams, he's the co-host of Real Science Radio, and he's a software engineer. He's going to give a talk on Saturday at 2 p.m. if you're interested in that. And you're going to be able to download the ebook, 20 Reasons to Question Plate Tectonics. There's a lot of reasons why plate tectonics doesn't work. And I'm a big proponent. It's like, hey, get all the information on the table, all the theories out there, and then let's just see which one's making accurate predictions. And if I had it my way, nobody'd get any grant funding until they made an accurate prediction. Once you had an accurate prediction, you're onto something. Otherwise, we're just throwing money down a big money pit. That's just me personally. Okay. And then he's also going to give a talk, the usefulness and problems of geophysical computer modeling. And he's going to give that at 1 p.m. on Saturday. And so again, I heard this one quote, I think it was a scientist who said, all models are bad, some are useful. So yeah, just check that out. Okay, back to the Earth one more time. Okay, this is the Earth, and the moon's tugging on the crust of the Earth, and the crust isn't broken into plates like today. So it's going to stretch and compress, stretch and compress, stretch and compress, and that's going to add heat. It's going to heat up, and like if I had a wire here bending it back and forth, it's going to get hot. Well, the crust gets hot, the heat has to go somewhere, goes into the water. The water gets hotter and hotter and hotter. It wants to boil, but there's no room to expand. And so at 702 or 705 degrees Fahrenheit, 3,200 pounds per square inch, it becomes supercritical water. And this is the key to the whole theory right here. Supercritical water. They've known about it for hundreds of years, but many professors don't know about it. It's not widely known. So it's a supercritical water where it's not really water and it's not really steam, but whatever it is, it dissolves things like crazy. So now it's starting to dissolve the granite, the minerals in the granite above and the basalt below. And it's starting to mix them together and make calcium carbonate, silicon oxide, sodium chloride, which are fancy words for limestone, chalk, quartz, salt. And so you're getting all that limestone. Remember that we talked about the limestone creating carbon dioxide? Well, it's just going to keep on recycling that carbon dioxide molecule over and over and over. And Brian Nickel does a really good job about explaining that on his YouTube channel. So now we're getting these layers of limestone and salts and silicates, all these minerals that are building up at the bottom of those subterranean water chambers. And it's getting stretch and compress, hotter and hotter, more and more pressure. The crust getting weaker and weaker. It's getting dissolved. And then it finally cracks. There's a crack in the crust of the Earth, and that crack goes in two directions at 3 miles per second. And within 2 hours, it went around the whole world. Yeah, and that crack in the water just erupts out of there. Walt Brown says that water was at 372,000 pounds per square inch. So it just erupts out of there. It just explodes out of there. And that's how we would get the flood. And then that's how we could get, how it could rain for 40 days and 40 nights. And people will say, well, if that happened, wouldn't it leave a mark on the Earth? And I say, yeah, it did. That's the mid-oceanic ridge. That's the mark that was underneath the crack of the crust of the Earth. Okay, and so now, and Walt Brown, you see how that circle there, it kind of comes together on itself. He thinks that's where it ended and stopped splitting. So he runs the movie backwards and figures it must have started up by Alaska. And that's where the crack went, and it went all the way around in about 2 hours. Boom, and now the water's just erupting out of there. And that's going to give us our sediment, layers of sedimentary rock. So now you get, see on the, excuse me, on Earth, you can never have a mountain more than 5 miles high, or a cliff more than 5 miles high, because it's going to crush the rock below. Well, these cliffs are 60 miles high. And so they're crumbling into this supersonic water going through there. And so the basalt is getting eroded off the bottom. The granite's getting eroded off the top. And it's also getting eroded off the sides. That's why there's more granite in that sedimentary rock, 65 parts to the 5 parts of basalt, because it's eroding the granite in 2 different directions. And so it's just going to crumble in there. It's going to go over our continents, and it's going to lay down these continent-wide layers of sedimentary rock that are actually worldwide layers of sedimentary rock. That's what happened. You know, if Randy Galuza, if he was still in school, he'd be asking his professor, hey, what process today is laying down worldwide layers of sedimentary rock? Yeah, that's not happening. It's not happening. Okay, and so now you got two cliffs 60 miles apart, and they're eroding. They're getting farther and farther and farther apart from each other. And so then there's eventually nothing pushing down on the mantle, and the mantle bulges. This is the next key to the hydroplate. There's nothing pushing down on the mid-Atlantic ridge, so that it's like lifting up a railroad track. The train starts to roll. So the continents start to slide. So you got North America and South America sliding to the west. You got Europe and Africa sliding to the east, and they're going to keep on going until they made resistance, and then they're going to buckle up. And that's why the major mountain ranges are parallel to the mid-Atlantic ridge. And if you notice that the Rockies are twice as wide as the Andes, I believe it's because North America slid over the mid-Atlantic ridge, mid-oceanic ridge. That's just my input to the theory. That's just what I think. So better study it out before but that's what it looks like to me. Okay, and so what's going to happen during that compression event? And keep in mind, supercritical water has 38% more viscosity than water. So it's a lot less friction there. It's like, it'd be like sliding on I don't know, an air hockey table or something. And so these continents are sliding friction free until they run out of water or meet resistance, or maybe they hit the other ridge, and then they're going to buckle up. They're going to go up. There's going to be a lot of rock is going to melt in the pressure and the heat, and that's going to make the oil and the coal. It's going to make the metamorphic rock, because marble is limestone heat and pressure. Diamonds are coal heat and pressure. Well, this is where you get the heat and the pressure. This is the compression ridge. And that we also find carbon-14 in all that stuff. It shouldn't be there. That stuff's supposed to be millions of years old, if not billions of years old. No, but we find carbon-14 in there. And they'll say, well, it's contamination. Well, no, because it doesn't matter which layer you take the coal from in the earth, it's got pretty much the same amount of carbon in it. If it was contamination, it'd be random. Have a lot and a little. And also diamond. How do you contaminate that? I mean, that's the hardest natural occurring substance on earth. And here's a folded mountain, Sullivan River in British Columbia. It looks like an accordion. That's sedimentary rock right there that got squished together while it was still soft, so it bent and didn't break. And then it dried out and it was mixed with a cementing agent and turned to stone. All over the world, all that sediment was mixed with a cementing agent and turned into stone. That's how you do that. Okay, and so now if you want to do a science experiment, see if it'll work for you, take your finest piece of china and bend it. See what happens. It's going to break. That's what shows. And these aren't broken. These are bent. And this isn't metamorphic rock. It didn't get that under heat. This is sedimentary rock. And that brings us to Gunnison Canyon. What crushed that big rock? Oh my goodness. Remember, those trees are 15 feet high? And that's not a tension crack. Tension cracks are straight. This is a compression crack. And in granite, the thing that's going to melt the first is quartz. So I believe that there's a lot of pressure. The first thing to melt in the granite is the quartz, and that filled up those, it looks like marble cake. And that's what happened at the Grand Canyon too, in the inner gorge, that Vishnu schist. Same thing. That's what happened. It got crushed during the compression event when it couldn't go any farther, but there's a lot of stuff coming behind it that just crushed it. Okay, and so then it gets crushed, it buckles up, goes up. So now you got sediment that got slanted on the angle that it went up, but yet there's still sediment that's sliding to the west. And so that's how you're going to get slanted layers underneath flat layers in the Grand Canyon. That's how that's going to happen. And how about the quartz rock? How did that get lifted up into the sediment? Well, that quartzite rock, it broke off. A lot of pressure, a lot of sand going that way, and then it lifted it up. And then it came to rest. And then the sedimentary rock turned to stone. And that's how you get that 5 to 10 ton rock lifted into sedimentary rock. And again, they don't put that on the National Park website. They don't put that in the science journals. They don't put that in the general ed textbook. Trust me, I've looked. This is an anomaly, and your theories should be able to explain those anomalies. And the hydroplate does it perfectly. And this is where it's at. Those are Walt Brown's, I believe they're his grandsons. And if you want to go look yourself, there it is. There it is. That should be in every textbook in the world right there. It's proving that those layers didn't get put down by millions of years. No way. Okay, the Mid-Atlantic Ridge. Let's talk about that. That got stretched in two directions. Well, how did that happen? Well, remember, there wasn't any weight pushing on it, so it bulged up. That's how you get those tension cracks there. And so that mid-oceanic ridge is rising up everywhere. Well, if something's rising up, something else has to get sunk in. That's the Pacific. What's happened? The Pacific Ocean sunk in, melting the inner earth. A lot of pressure, a lot of lava. That's why you got the ring of fire going all the way around the Pacific Ocean. That's why you got the Mariana Trench. That's how it formed. It got sucked in because the mid-oceanic ridge was getting pushed out, was rising up. So it sucked in the Mariana Trench. And that's why most of the trenches are in the Pacific Ocean and not in the other oceans. And that's why you got all those volcanoes there, because there's a lot of rock that melted there. And it even sunk in a continent, Zealandia. According to Life Science, Zealandia, sunken eighth continent, reveals its buried secrets. And Walt Brown had predicted you're going to find granite in the Pacific Ocean. And they said, no, 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 no. And guess what? There they did. They found it. They found evidence of land-based fossils on Zealandia. So that was out of the ground at one time. And then it got sucked in. And it's about the size of India. Okay, and if you're interested about what the hydroplate did in the ocean, Matthew Wellborn, he's got a PhD in electrical engineering in the air, and he works in the aerospace industry, and he's got a talk Friday tomorrow at 4 p.m. Eastern. I'm so excited to listen to all these. And he says the surface of the ocean floor has many strange features that are best explained by a bulging mantle and by sliding hydroplates. Bulging and sliding explains the oceans. Well, the Grand Canyon is explained by bulging and cracking, and we'll get to that. And so then the water, which was covering the earth, rushed off the continents to fill in the Pacific Ocean, carving these valleys. That's how you get these submarine valleys. And Walt Brown says the continents were higher back then, and the continents have sunk in, and the oceans have rose up. That's how they got buried in water. And also during the Ice Age, the ocean level dropped 125 meters. And so there'd be erosion there too. And then you could go anywhere. There's land bridges everywhere. And that's how the kangaroos got to Australia, beat the lions there. Okay. Because marsupials, they can have kids and keep going. Predators, they typically have to stop. So they can get behind. Okay. How does a canyon form under 2 kilometers of ice? Well, all the water gushed off of Greenland, cut the canyon, and then the ice age filled it up. And the same thing happened in Antarctica. Every depression would have water in it, and then the ice age came and started dumping snow on it. And it was just a matter of time as what would happen first. Would it freeze to the bottom, or would there be enough insulation on top to keep it from freezing? And guess what? The ice won. There's enough insulation on top. Okay, and here's just a side note, another climate change nightmare. This is from the Washington Post. 91 new volcanoes beneath Antarctica's ice. So if Antarctica's ice is melting, it might be one of those 91 new volcanoes. And again, I'm forgetting all the information out there. So let's also consider the volcanoes in the Pacific, the sunspots on the sun when we're talking about climate change. And I encourage everybody to read Inconvenient Facts by Gregory Wrightstone. He pretty much dismantles every one of those icon alarmists, and also CO2 Science. And again, I'm forgetting all the co2science.org. I'm forgetting all the information so you can make informed decisions. And it's like that's saying, beware of one hand clapping. See, there's 2 sides to every story, right? But if you only hear one side over and over and over again, it's probably because the other side is being censored by those who have a financial or powerful interest in it. But that's a rabbit trail. Sorry about that. Okay, so there's no glacier in Alaska. Okay, and what caused the ice age? Why is that? Okay, now to get an ice age, very counterintuitive. You need warmer oceans and cooler continents. You see, an ice age is it just snows more than it melts year after year after year after year. And in 400 or 500 years, you got the ice age. Well, how are you going to get warmer oceans? Okay, well, that's going to be because of the hydroplate. You got all those volcanoes, all that stuff. And so you got more precipitation. Well, then how come it comes down as snow? Well, Walt Brown says the continents were higher, therefore it was colder. Every 1,000 feet, you're going to drop 3 degrees. And then also there's going to be, and why didn't you have glaciers in Alaska and parts of Siberia? Well, that's because precip came down as rain. It hadn't gone far enough inland to get cold, or it might not have been high enough elevation for that to freeze it. So it came down in Alaska and Siberia. Precip came down as rain. Okay, and then so then you get the ice age. Okay, so that causes the ice age. And again, once an ice age starts, why would it ever stop? That's a tough one if all you got is blind chance and random collisions to work with. But it fits here. Okay, well, how come the ice age did stop? Well, over time, the oceans cooled off. So there's less precipitation, therefore less snow. And also, I didn't tell you about what else makes them cold. That would be the aerosols from volcanoes. Volcanoes erupting put a lot of aerosols into the atmosphere, and that's going to reflect a lot of heat back into outer space so it doesn't get down to the earth. And in 1815, they had a year without summer. Mount Tambora in Indonesia erupted and put so much aerosol into the atmosphere that in New England, the snowstorms came in June and ice formed on lakes in July. The year without summer. That was one volcano. Could you imagine what hundreds or thousands of volcanoes, how much aerosols that put up in there? Okay, so why did the ice age, that made it the continents colder? Okay. All right, and so why did the ice age stop? Again, the oceans cooled off, less precipitation, less snow, and then the atmosphere cleaned up. So you're getting more heat getting down into the earth. And then so you got 1 or 200 years for the ice age to melt, and we're still recovering it from it to a certain extent. Okay, the frozen mammoths. How does it freeze standing up? How did it get so cold so fast during late summer? That would be the cold hail. Cold hail. Hydroplate says some of that theory says some of that water was shooting up with such tremendous force. And it's more than water, it's erosion, it's mud, it's limestone, it's carbon dioxide. When it becomes frozen, it becomes dry ice. And some of that stuff shot up out of, it's going up so powerful, it got out of it broke through our Earth's atmosphere and went out into outer space, which is a huge heat sink, and got super cold. And then gravity took a hold of it and had it come down on the mammoths. That's how you flash froze them there, and it just got buried in dirty hail, muddy hail, and buried them to the ground. And Walt Brown says you'll never find coal or like fossils underneath them. He says that was the land that was before the flood, is what he says. That's a theory. That's a neat prediction. See what happens. And I think there was some pushback on that. And so again, I'm just throwing it all out there. You might want to check that part of this theory out. That one might not be as solid as other parts. And there could be parts that are wrong. And he's the first one to admit it. It's like some of this could be wrong, but I think the overall concept is solid. Okay. And so so it froze this temperate animal to the ground. How come it didn't thaw out? That brings us to the big roll. Okay, see, the mountains on the northern hemisphere and southern hemisphere pretty much cancel out, except for the Himalayas. We'll let that red dot represent the Himalayas. Okay, that's a weight on a bowling ball. And so you got a big mass on a spinning object. That mass is going to want to try to get to the outside. So what's happening is something that's on the top is going to the side, which means something that's on the side goes to the top. And so what you're going to have is, see how wide that went? What you're going to have is Mammothville, where the mammoths are fat and sassy, lots of food, lots of water, gets moved up to Mammoth Chill during that big roll, thanks to the Himalayans. And that made it to Mammoth Chill. So they never thawed out. And I believe that the Earth rolled 3,000 miles because that's okay. So what happens? Yeah, and so that brought the mammoths up to Mammoth Chill. It brought Axel Island and Ellesmere Island up there. And that's how the snakes, the tortoises, alligators, the redwoods, they didn't live there. That's just where they ended up after the big roll. Same thing with tropical palm tree. Tropical palm trees, this is where Antarctica was before the flood, and then it rolled, and then that's where it ended up. That's also how we got the 90 East Ridge, because the equator has a bulge at it. I think it's 28 miles more diameter that way, or circumference, not quite sure. But there's a bulge at the equator, and as the Earth rolled through the bulge, it cracked. Therefore, you got the 90 East Ridge pointing directly at the Himalayas. And that's where it is. That's the 90 East Ridge. Oh, and you St. Cloud State students, that's a picture from the bottom of the Math Science building. Yeah, it's very interesting. So you can check that out. Okay, and then the 90 East Ridge. Okay, that's where it's pointing at the Himalayas. So then you got these mountain ranges, and it's pushing directly, you got the mountain ranges parallel to the mid-oceanic ridge, and next to the mountain ranges, you got these plateaus. How do those form? It's hydraulics, because mountains have a big mass on a small base, and that causes it to sink. Well, if something sinks down, something's got to rise up, puts a lot of pressure on the side. That lava can't go down, goes to the side, puts a lot of pressure on the plates next to the mountains, and they block fault up. So what's the mechanism? That's hydraulic lifting. What's the force? It's gravity. Okay, and so that fits. And if you look up plateau in the dictionary, it says at least one side is steep. Yeah. And I think on the other side, you got a mountain. That's how I define it. And so the block faults up. Some of that lava will get to the top, go through those cracks and get to the top, and put lava on top of those sediments. And then if there's a big flow of water, like during the Great Denudation, where those lakes are overflooding, it's not going to wash away the lava. It's going to wash away everything else around it. And that's how you get Red Butte to form. That's right. And again, Red Butte is right next to Grand Canyon. That was formed during the Great Denudation, because to form Grand Canyon, you got to remove 2,000 cubic miles of sediment before that canyon can get the canyon to move 800 cubic. And so that brings us to Grand Canyon answers. And I gave this talk a couple of weeks ago in Denver at the Rocky Mountain Creation Fellowship, and you can see it on their YouTube channel. I also gave it at a Sunday school, so you can see it on my YouTube channel at Solidify Your Faith. And so why are the layers so flat? Okay, now hydroplate would say liquefaction. Okay, and that's when, because keep in mind, in a worldwide flood, the continents don't break up high tide. You could have some huge waves going across, 200 feet of water. Just think of the pressure pushing on the sand, pushing it down. And then when the trough goes by, all that pressure is released. So all that water comes up, and then it gets pushed down, and then it comes up, and that could sort it into layers. And I had talked about that, and somebody asked me, well, wouldn't that get rid of the cross bedding? I thought, well, that's a good question. I don't know. You scientists, check that out. I'm the megaphone. So you guys work on that. And speaking of, and also Henry Morris, there's a flume in St. Paul where they study the Mississippi River and how that's laying down sediments. I'd love to see it. And he saw how, I think if I remember right, he saw how multiple layers were being laid down at the same time, I suppose based on their density. And maybe that's what happened during the compression event. Maybe during all that water moving and all that plates vibrating, maybe that sorted it into those different layers. And speaking of limestone, the red wall limestone in the Grand Canyon, it's 500 to 800 feet thick. It represents 50 million years. So let's just do some simple math. That would be 1,000 years per foot is how it gets put up there. And do some more math, and that's 8,300 years per inch. So it's formed really slowly. And what I didn't see on the website was that they found nautiloids. Steve Austin, he documents how they find nautiloids, must be by the billions. He says one fossil per square yard. So they're everywhere. And he's found them all the way out to Las Vegas. That's right, one per square yard. And they seem to have a directional orientation indicating that they were experienced a mass kill event. They think it's an underwater landslide. And that could be that compression event. And it goes on to say that 15% of them are standing upright. Vertical nautiloids. They're not going to stand upright for tens of thousands of years. Remember, 8,000 years per inch? They'd probably have to stand there for 80,000 years. No, it's gonna decompose. And while we're on fossils, that dead deer on the side of the road, is that going to turn into a fossil? No. It's going to get scavenged and decomposed. It's not going to be there. The only way a fossil forms is if it's buried rapidly. Therefore, any layer of rock that has fossils in it was laid down rapidly. And that's the geologic column. Those fossils are not signs of millions of years. That's a sign of a flood. Well, anyway, Steve Austin, he went and he documented where he found all these nautiloids, and they gave it in a report and gave it to the park, the Grand Canyon Park. And then they pulled his permit. They won't let him do it anymore. Isn't that odd? Isn't it? Well, that's the elephant in the room. You can't do stuff that undermines their company line. And so when that elephant gets kicked out of the room and we have the freedom to think clearly, that's when the golden age of science will begin. Okay, and how come you don't have Grand Canyons everywhere? It's because you need a lot of potential energy. And that's where the Colorado Plateau comes in. And there's two huge lakes up there. And there's all these national monuments around there. You got the Grand Circle with Zion and Bryce and Arches and Canyonlands. But let's take a look at Monument Valley. Remember those mesas, buttes, and spires? How'd they form? Well, they used to be under a lake, and that lake could have been really deep. I mean, Grand Junction, that was 1,000 feet deep. So there could have been a lot of water. And Walt Brown says there's 1,400 feet of sandstone under those mesas. 1,400, so that would have been 1,400 feet of sand when that lake was there. And then the lake drained, and so the water comes to the surface, and it erodes off the surface. It's not going to, if there's something on top, hard on top, it's going to erode around it. That's how you got the mesas, buttes, and spires. This is the bottom of a lake bed. And that was the bottom of Grand Lake. Okay, let's take a look at petrified forest. That's in the bottom of Hopi Lake. Walt Brown says that the solution has a lot of silica in it. The lakes had a lot of silica. And when the lakes cooled off, the solution had to go somewhere. And so it went into the wood. And I believe those were the trees that were, I don't know, maybe they're still from before the flood. I'm not sure. Okay, and if you're interested in that Grand Circle and that what we just talked about, we're going to show a video. This is Mike Snavely's video. We're going to show it at 6 p.m. tomorrow. And it's really, really good. He goes to all those places, has such really good video of it. I never even realized that those places were there. And I believe that you should get, this is a copyrighted video, so you should not record it. But if you want it, and it'd be a great resource, it should be in every library if you're a creationist, missionimperative.com. That's where you get that. And so if you're interested in more of those geologic features at the Grand Canyon, but back to Grand Canyon, there's a lot of water up there. Could have 3 Great Lakes worth of water there. And again, Grand Junction was 1,000 feet deep. So there's a big lakes, very deep, a lot of potential energy, a mile high. And then let's take a look at the funnel. The Grand Lake breaches. There's 3 ways it could have breached, but it doesn't matter for this talk. Okay. And it breaches. And so let's just start the water starts flowing faster and faster. A rock gets caught in a vortex and digs deeper and deeper. And that's how you get that pothole on a 2,000-foot cliff. So then it erodes away from the pothole, erodes 2,000 feet down, 2,000 feet of sediment. Just figure out how much that weighs. And it just kept going down and down until it hit the hard Kaibab limestone. That's why I don't think this was after the flood, because it needed the limestone, or the Kaibab limestone, to harden. Okay, so maybe it's 100 years, maybe 200 years later. Okay, so then the water's cutting down, and then it hits the limestone. It doesn't go down any farther, so it goes wider. And that's how you form the funnel. And now 2,000 feet of sediment are removed. Just imagine how much that weighs. And so that weight is gone. So now the Kaibab limestone cracks. It bulges. First it bulges up, and then it cracks, and then the water goes through the crack, which goes directly under, it goes down under Hopi Lake. It undermines the Hopi Lake, which is 250 feet higher than Grand Lake. So now this thing's dumping out with tremendous force, probably 2,200 feet, and it's just sheet eroding everything. This is the Great Denudation. This is how the Red Butte formed. Just eroding everything there. So now there's no weight on this area. And so the Kaibab Plateau, I think it's more of an upward, forms. Okay, so it rises up, and let's take a look at that circle in the crack. So now the stuff in the west has risen up. So now the subterranean water is flowing downhill to the north, because it rose up to the on the west there. So it's flying downhill to the north, and then it meets where the river is and does a quick U-turn and then flows south. That's how you get the barbed canyons. Okay, and then again, there's nothing pushing down on that Kaibab limestone, where that Kaibab Plateau forms, so it cracks. All right, so then the river runs through that plateau instead of around that plateau. It goes through it because that's where it cracked, and now it's eroding everything there, and it's cutting below the water table. And so that's how you get the side canyons with no river. It's all the water gushing in from the side. It's eroding everything. Okay, and now there's nothing pushing down on the Grand Canyon. It cuts all the way down to the basement rock, the Vishnu schist, and it should get wider because it's softer sediment to the sides, but it doesn't, because the Grand Canyon, there's 800 cubic miles of sediment missing now from the Grand Canyon. Okay, so there's nothing pushing down on that basement rock, so the basement rock cracks. That's how you get the inner gorge, 46 miles long. It's just bulging and cracking. There's nothing pushing down even on the basement rock, so that cracks. That's how you get Grand Canyon. How do you get inland seas? We're going to answer a lot of questions with this one. Okay, how do you get lineaments? How do you fuse past iron? Okay, we're going to answer all of them right now. Okay, it all depends on quartz. See, granite's made of quartz, feldspar, mica, and hornblende, and they all have different specific gravities or specific densities, and which proves granite was never molten. You know those theories of blind chance and random collisions? They say the earth was a molten blob. Well, guess what? Granite was never molten. Otherwise, those 4 would have been in a layer based on their specific densities, but they're not. They're all over the place. And there's a book out there, Creation's Tiny Mysteries. And the guy said, if you can prove this theory wrong, if you can make some granite, and nobody can. And you melt granite and you get rhyolite. All right. So there's quartz is 27% of granite. And quartz is a really, really interesting material because it's piezoelectric. Piezo meaning pressure, and electric, I suppose, meaning spark, which means if you pull on that quartz, it's going to make a spark. And if you push on that quartz, it's going to make a spark. That's how they do the gas lighters, for the barbecues. But anyhow, So the granite is going to be in tension and compression. It's going to flutter during that during the hydroplate event, and the water's gushing out. The edge of the continent, the edge of the plate, is going to slam down and block the water, and then the water pressure is going to build up, and then it's going to make it shoot up. So they call this fluttering. And so you're going to have a lot of pressing, a lot of compression, and a lot of tension. And so it's going to create a lot of sparks. And that was one of the criticisms about the hydroplate theory, is there's no lightning in granite, no sparks in granite. Well, they must not have read the Smithsonian article. Why do lights sometimes appear during an earthquake? You know, mysterious flashing earthquake lights may be explained. What causes eerie earthquake lights? Earthquake lights linked to rift zones. So during earthquakes, they see this electrical activity showing up as lights. Electrification phenomena in rocks. Bizarre earthquake lights might finally be explained. Yeah, I think it's the quartz and the granite. And that might be doing this electrical charge. That's why the atmosphere gets ionized, and there's electromagnetic signals prior to the earthquake. And Bob Enyart made a prediction. He says they're going to be able to predict earthquakes based on this model here. And if you're interested in earthquakes, Kevin Lee, who taught engineers at the nuclear engineering department at a naval shipyard, he's going to do a talk on earthquakes on Saturday at 8 p.m. Eastern time. So this is so exciting. I'm doing a big brush overview just to give you the concepts, and then you can dig deep with those guys. And so the fluttering, it's going to slam down and it's going to Z-pinch some of the material, and we'll get to that in a little bit. Such pressure, and it's going to be kind of like melted rock, and it's going to go to the side, and then it's going to build up pressure, and then it's going to get shot into outer space. And guess what, folks? That's how we get the chondrules in space. It was not formed in space. It was formed in the subterranean water chambers and then got propelled into space during the eruption event. Okay, now how do you fuse past iron? Okay, and I am so thankful for this. That is not in my wheelhouse at all. So I'm very grateful that Dr. Joshua Spencer is going to be giving a talk on the origin of continental radioactivity. That's going to be tomorrow at 8 p.m. That's another one you don't want to miss. Yeah, they think the radioactive material was formed during the flood, because you don't find it in the oceans and you don't find it all through the earth. It's typically around granite. So how did that happen? And I'll just give you a real quick overview what I learned from Brian Nickel. Supernova capability, you can get up to iron, but not any farther. We read about that. They don't know how it happened, but they can do this in nuclear fusion. It's called Z-pinch. They take some pure copper and they hit it with something going really fast, really hot, and then it makes 94 natural elements and super heavy elements. And the interesting thing is it's the same ratio of elements as we find in the earth. Very interesting. And so then the stuff that's radioactive, it decays into the valley of stability. And I hope you guys know what that is. Okay, so how does this happen in nature? This is like lightning, plasma. When the electrons aren't on the neutrons or whatever plasma is, but lightning, spark goes from the clouds to the ground and the air expands a little bit. The lightning goes through and then the air does a thunder clasp. That's where we get the thunder from. It crashes back on itself. Well, the granite's not going to do that. It doesn't have room to expand, but it kind of pushes. It's got a rebound. So it kind of makes it go out and then it slams them back together. And that's how you do it in nature. All right, so watch Spencer's talk if you want to learn more. Okay, and so that radioactivity is going to make the crust very weak in some places, and those weak places are going to explode with tremendous force, and that's how we get the inland seas. And because there's salt on the bottom of all of those, and I believe that salt is from the subterranean water chambers. Okay, and that's also how we get the free neutrons for deuterium. Remember, hydrogen's a proton, electron. Where do all these neutrons come from to make deuterium? Well, that's happening during that radioactive process. And how come it's diluted in the ocean? Well, it's because half of the ocean wasn't down there. So the stuff that did come up that had the deuterium, it got diluted. And the stuff that didn't get into the ocean, it's got twice as much. Okay, now some of this stuff went up with such tremendous force that not only did it escape our atmosphere, it escaped the gravitational pull. And this is stuff like granite and basalt and carbon dioxide, which is frozen. So it'd be dry ice and water and ice. And so you got like these dirty snowballs going through the solar system. What are those? What are described as dirty snowballs? Comets. And that's why we find stuff from the earth in the comets, even cubonite. And this explains that perfectly. That's how you could get that hot water. And it and hot water not turning to steam, and there wasn't any room to boil, so it made that cubonite. And again, if you got to see this Saturday, 3 Eastern, 2 Central, 1 Mountain, and noon Pacific, the origin of comets. You really, really, really need to see that one. I think that's the talk of this conference, and we'll explain why later. How do you get rounded boulders in Comet 67P? Same thing. That the boulders were going through that fast flow of the water, supersonic water, and got shot up into outer space. And they call them dinosaur eggs if you look at the bottom right there. Dinosaur eggs. No, they're not. That's from the hydroplate. Okay, and so how come the short period comets are mainly going in the same direction as the Earth, prograde? Well, let's just pretend, make it simple math here. Let's pretend the Earth is a train going 100 miles an hour. And we got something, we shoot out a bunch of stuff going 50 miles an hour. Okay, and it doesn't matter which direction you shoot it in, it's going to go in the same direction as the Earth. So those short period comets got shot up with not a whole lot of velocity. So they just keep going or in the same direction as the Earth. But now let's say we shoot it out at 150 miles per hour. Now there's going to be more that can go in the other direction because we're only going 100 miles an hour. But it's still going to be mainly in the same direction. That's what we find, 70-30 mix. But now let's say we shoot it out at 500 miles per hour. Now it's going to keep on going. It doesn't matter which way we go because it's going to overcome the 100 miles that we're going. Okay, and that's how we get Naiku. Beyond Neptune, the chunk that's orbiting in the wrong direction. No, it's not orbiting in the wrong direction. It's only orbiting in the wrong direction if your only way of explaining it is blind chance and random collisions of atoms. Yeah, then it's going to be the wrong directions. But for the hydroplate, no, it makes sense. And if you're interested in trans-Neptune objects, I encourage you to come to in here. This is going to be Saturday at 5. Dr. Robert Brown, this is Walt Brown's son. And I'd love to ask him, hey, what was it like growing up with today's Isaac Newton? I would love to hear that. But he's a professor of astronautics at the Air Force Academy. He's a brilliant guy, just brilliant. So come on in and see what he has to say about trans-Neptune objects. Okay, and how did the asteroids get moons? How do you get these peanut-shaped comets, which are so hard to explain? It should have blown each other to smithereens, which it should. You know, if two objects are coming together, they're going to break apart. You know, there's that the asteroid belts, they're not turning into planets, and Saturn's rings are not turning into moons. They're falling apart. That's what normally happens in space. The only way you get them to come together gently is if they're all going in the same direction and the same speed. And then eventually the biggest rock is going to have the biggest sphere of gravity, and it's going to gradually attract everything around it. That's how you get the peanut-shaped asteroids, and also they could capture a moon that way. And if you're interested on the origin of the asteroids and their connection to the features of the moon, Doug McBurney, he's another co-host of Real Science Radio on KLTT, he's going to explain that Saturday at 4 p.m. Man, this smorgasbord, I'm just so excited for you guys. I mean, drink deeply from this knowledge. These guys are sharp. Okay, how do canyons form on Mars from water erosion? Okay, well, some of this water from the Earth ended up on Mars, and some of it flashed into steam and was gone, but some of it got soaked into the ground and turned into ice. So there's water, ice in the ground. And then if it gets hit by a comet or a meteorite, it's going to have some heat there. That heat's going to melt that water that's in the soil, and then it's going to run down the valley side, and it's going to cause erosion, water erosion. So we can explain that. Okay, and people will say, well, if this really happened, all that stuff shooting out, wouldn't it leave a mark on the moon? Absolutely, and it did. I mean, the near side has just got all those lava flows and moonquakes, and the far side hardly has any. And when you look at a density model of it, the near side has been shot with buckshot, not so much on the back side. Okay, so yeah, the moon got pounded. And if you're interested in that, a creationist explanation for the features of the moon by Doug McBurney. That's going to be Saturday at 4. And I remember Bob Enyart going to the Creation Museum, or the Ark, and I think it was the Ark Encounter, and he was so disappointed that they put that the moon was beat to pieces. You know, it's all full of craters. He was disappointed that they had that way during Creation Week. So hopefully they get that fixed. So anyhow, a good theory can make accurate predictions. And in science, the currency of science, it's accurate predictions. And Walt Brown has made 56 predictions, specific predictions, not like the sun's going to rise tomorrow, or this is going to happen in 2,000 years, or whatever, specific time-sensitive predictions. And he's had 6 of them that were confirmed. One of them was wrong based on a mathematical error, But he predicted accurately that there'd be pooled water under mountains. And it was confirmed. Deep channels under Bosporus and Gibraltar, and it was confirmed. Salt on Mars, confirmed. Asteroids are flying rock piles. That's, yeah, check out Kevin Lee's for this one, and it was confirmed. And water inside, rocks on asteroids and comets are rounded, confirmed with 67P. Water is inside large asteroids, confirmed. And carbon-14 in old bones, and that's been confirmed. He's made all those predictions. Oh, and by the way, they also find nerves in dinosaur bones. And Bob Enyart, he went on a cruise with these PhDs, a bunch of PhD crews, and he was, Bobby's talking to everybody. He said, what do you think of these dinosaur blood and dinosaur bones? And a lot of the professors had never heard of that. PhDs had never heard of that. So he shows them on his phone, and their mouths drop to the floor because they realize blood cells can't last millions of years. That's right. Dinosaurs did not live millions of years ago, according to observational science. And so there's carbon-14 in there, there's blood cells, there's nerves, there's bone cells. Mark Armitage, he found some bone cells in there, got it published in Acta Histochemica, and they fired him. Yeah, he was out of college, they fired him. It's like, what did I do? I just showed what I found. Yeah, but they fired him. So he sued him for wrongful termination, and he won. But he's not teaching there. You remember that institutional line? That's really holding back science. Okay, NASA discovered an Earth-like composition of comets, fulfilling Walt Brown's published prediction that they would find one of the most common minerals on Earth, olivine. So again, time and time and time again. But there are objections to this theory. One was what the professor told me. I don't believe the assumption. I don't believe the water was under the oceans back then. Like, my response is, well, why not? There's water under the oceans today. You got these black smokers coming up really hot, and if it's coming up from under the oceans, where does it have to be? Below the oceans. There's water under the oceans today, and there shouldn't be any water more than 5 miles deep. Okay, because granite's maximum strength is 2,300 psi, and there should be no significant continental water expected below 5 miles in depth, because at that pressure, it's going to be like putty. It's going to seal up all the cracks. And yet Germany and Russia drilled a hole over 5 miles deep, and what did they find? Crushed granite and salt water. I think it was salt water, but they found crushed granite and water. And they also believe there's water beneath the Tibetan plateau. Shouldn't be there. If all you got is blind chance and random collisions of atoms, shouldn't be there, but it is, and it fits perfectly with the hydroplate theory. The other objections are the atmosphere would have gotten too hot for life. The oceans would have boiled and everything would have died. There would have been so much pressure, it would have blown the continental, or it would have blown the crust right off of the Earth. Those are some objections. And Brian Nichol does such a great job. And by the way, all these graphics, Brian Nichol did them. He's did a great job. Okay, but they got to realize that's they're missing thing. There's directed energy. There's also air is a good insulator. This is Brian Nichol's hands. He's that close to 1,800 degrees Fahrenheit. And so air is a good insulator. He said he could have held them there until the gas ran out. And there's also directed energy. Directed energy. Look at all that energy on that rocket. It should have blown that rocket to pieces. No, it was directed. Like the hydroplane, when it was shooting up from the fountains of the Great Deep, it was directed. It was going in a certain direction at incredibly fast speed, so it didn't have much interaction with the atmosphere or the ocean. And also you got big fat. It shows basically that as things expand, they get cooler. I believe it's the Joule-Thomson effect, and none of those critics took that into account. And so do the math, these smart guys. But again, if you're interested in that, Brian Nichol does a really good job getting interviewed on rsr.org. Okay, so the hydroplate perspective. When I look at the Earth, I see the hydroplate. I don't see chance. I don't see blind chance and random collisions of atoms. No, I see the hydroplate. And so I've got my perspective. This perspective fits. And again, I'll repeat it. If we have the wrong perspective of the past, which the big boys do, NASA and everybody else, and education system, we're going to have a wrong perception of the present, and it'll mess up our focus on the future, and we'll make a colossal mistake like NASA did. But if you got the hydroplate perspective, everything makes sense. All those questions are answered simply. And Occam's razor, the simplest one is the best one. Okay, and again, the origin of comets. This, I believe, perfectly shows how there's two perspectives of the Earth, of the past. One is blind chance, random collisions of atoms. The other is hydroplate. And you get to see two views and then an experiment, see which one's right. So again, watch that. Kevin Lee's talk on the origin of comets. And so, in astronomy and geology, it's all falling apart. It's not, their paradigm just doesn't make sense. And it's also falling apart in biology. These animals, they can go from blind cave fish to fish with eyes in one generation. How in the world can you explain that with evolution? And you find these words: regulated, rapid, repeatable, reversible, targeted, predictable changes, not only in the creation literature, but also in the evolution literature. And so I'm trying to get, and ICR.org, they've got some great articles on there. Just go into there and search engineered adaptability. It's incredible. They're kind of cutting edge on this. And basically, we're looking at the animals like an engineer. There's stuff engineered into them to adapt. And they sense the environment that they're in, and they make turn on and off the appropriate changes. That's not mutations. And I tried, and they, Creation Research Quarterly, they did a story on that too. And I'm trying to get these peer-reviewed creation journals into St. Cloud State and St. Cloud Community College, but they won't have it. It's like, well, our budget doesn't allow for that. Well, this is free. Sign up for Acts and Facts. So if you're a student, ask them to get that. And if you're a student, anybody, go into ICR.org and sign up for their Acts and Facts. It's a great, 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 great resource. Oh, and also, if you want to be involved in this on any campus, but specifically, well, St. Cloud State or any campus, I'll go where and try and get the truth out there. You can email me. I'm the Grace Campus advisor, Grace Campus Fellowship advisor at St. Cloud State. And if you're a student there and you want to be involved, you want the truth to get on campus, let's talk, because we can make it happen. But we need the students' help to make it happen. And COVID we're starting from scratch back then. So Grace Campus at proton.me, and we'll get the truth on campus. Because remember, one hand clapping, that's all they got. Blind chance and random collisions, that's it. And it doesn't make sense. And also, if you're watching this online and you want to get something at your school or your church or your college, you can email Grace Campus at proton.me. Okay. And the evolutionists know that they can't explain it by evolutionary processes. They're so worried. I mean, they're so just, they started a new website called The Third Way of Evolution because they know they can't explain blind fish to non-blind fish in one generation. They can't do it. So the thirdwayofevolution.com, this is what they say. Other mechanisms are essential for a comprehensive understanding of evolutionary processes. Absolutely. Yeah, alternative ideas of the evolutionary process is what they need. And we've got it. And yet the big boys won't allow it into the classroom. They've got their company line, the blind chance and random collisions. That's all allowed. And again, that's hindering thought. That's hindering science. Once we get rid of that elephant in the room, man, the golden age of science is going to begin. Okay, so why aren't we hearing about this? Well, maybe this is why. Walt Brown, he was an evolutionist for most of his life. And then back in the 70s, he's driving through South Dakota and he hears on the radio that somebody found an ark on a mountain. He thought, what a nutcase. That's crazy. But in South Dakota, there's not much to do besides watch the wall drug signs go down. You do the countdown to wall drug. And so I believe, and Robert, you can correct me, or Dr. Brown, you can correct me if I'm wrong, but I believe he was going through South Dakota with nothing else to do. So he just did a mental exercise, just played along. Okay, if you found an ark on a mountain, that would mean the whole earth was covered in water. Well, if the whole earth was covered in water, that meant there was a whole bunch of plants and animals that got covered in mud and turned into fossils. And he thought, wait a minute. If fossils are evidence for a flood, where's the evidence for evolution? And he began to ask his highly educated colleagues, remember them? What evidence do you have for evolution? And after 2 years of asking that question, he didn't have any evidence. And so he came up with this theory. And this theory has biblical support. In Psalm 136, to him that stretched out the earth above the waters, the earth was stretched out above the waters. And also Psalm 75, the earth and all the inhabitants thereof are dissolved, and I bear the pillars of it. Bear up the pillars. Those are the pillars, I believe, where the granite was touching the basalt, is what Walt says. And he gathers the waters of the sea together as a heap, and he lays up the depth in storehouses. So this is the water that's the storehouses, is how I interpret it. He gathers the water as storehouses, and that's what flooded the earth. It's not the lava. There's some creation organizations that say the fountains of the great deep was lava. Where do you get that from the Bible? I believe this clearly says that the fountains of the great deep was water. Water. So anyhow, for he founded it upon the seas and established it upon the floods. That's Psalm 24. And then Genesis 7:11, in the 600th year of Noah's life, in the second year, in the second month, the 17th day of the month, the same day were all the fountains of the great deep broken up, and the windows of heaven were opened. Yeah, the fountains of the great deep. I believe that was water. Where'd the water come from? It came from inside the earth. Where did it go? It went into the oceans, mainly the Pacific Ocean. Okay, and if you're interested in the flood, we're going to show that video Saturday at 11:45. This is a Mike Snavely video talking about where the water came from, where the water went, and it's titled The Horror of the Flood. Again, this is copyrighted. Do not copy it. Do not record it, but I encourage you to buy it from missionimperative.com, missionimperative.com. And this is one, or who shuts up the sea with doors when it break forth, as if it had issued out of the womb? The sea breaks forth. That could be the fountains of the great deep. And hast thou entered into the springs of the sea? That's what God asked Job. The springs of the sea? How did they know there were springs in the sea? We didn't find them until 1977. See, when the Bible talks about science, it's right. And they had actually opened the door to oceanography. Matthew Murray, he read in Psalm 88 that there were paths in the sea. And he thought, well, if God says there's paths in the sea, I'm going to find them. And he found the ocean currents, started a brand new field of science called oceanography. And when you look back at the who's who of science, they were creationists. Newton, Babbage, Pascal, Pasteur, the who's who. They were creationists, and yet now they won't allow the creator in class. And again, it's really limiting science. It's really limiting thought. The sooner we get rid of that elephant, the better off we're going to be. And then in Jonah, it says, I went down to the bottoms of the mountains. And that's, how did they know there was mountains in the sea? How would you know that? It's like when the Bible says he hung the earth on nothing. That's perfect example, perfect explanation. It's not a turtle on a turtle on a turtle. How would you know that back then? And then this one, this is Psalm 104. The waters stood above the mountains. At thy rebuke, they fled. At the voice of thy thunder, they hasted away. And people will say, I mean, could you imagine the sound of mountains forming, how loud that be? At the voice of thy thunder, they hasted away. Yeah, I believe this is the flood event. The compression event is what I think it's describing. But some people say, no, it's a creation event. But keep reading. They go down up by the mountains, they go down by the valleys into a place which thou hast founded for them. Thou hast set a bound that they may not pass over, that they may not turn again to cover the earth. Well, if that's creation week, there should have never been a worldwide flood. No, this is the flood event. And keep in mind, there was a flood. Back then, there was judgment. And there was judgment. And you could have got rid of, there was the flood, there was judgment. And you could have escaped that judgment by being in the ark. That's a picture of Christ. There's a coming judgment. God put the rainbow in the sky saying, I'm not going to flood the earth again. I'm not going to judge it that way, but there will be a judgment by fire. And I believe that that Jesus is the way to escape that. You need a payment for your sins, and Jesus paid for that on the cross. And that kind of is where this theory goes to, and maybe that's why people don't want to talk about it. They want to have a different perspective of the past instead of a biblical perspective of the past, and they need to toe the line or they're gone. Just a thought. Okay, and here's some resources where you can get more of this information. Again, hydroplate.org, that's how you got this these links, and also rsr.org, my favorite site. And you can go into rsr.org/HPT. So on one page, you have all the information you need about the HPT. And there's criticisms of it, and they publish that. And then you go into rsr.org/answers and see these criticisms. And if you like visual stuff, Brian Nickel is top of the line on YouTube. I got my stuff on YouTube called Solidify Your Faith. But this is what Brian Nickel, I think we talked about this earlier. He's got the origin of radioactivity, comets, 90 East Ridge, limestone, Grand Canyon. Excellent work. And thank you for the graphics, Brian. You do great work. rsr.org/HPT. We talked about that. You're going to have all those interviews. They are so fun to listen to, and they're all available for free. But I encourage you, when you listen to it, I encourage you to start downloading and supporting RSR so it can keep on doing what it does. And also so you have a copy of it in case it ever gets taken down for whatever reason. And we've seen that happen. It's got a sad world we're living into. And it's got a list of the answers to hydroplate objections. Then realscienceradio.org/answers. This is where you're going to see a list of published criticisms. So you can go to that page and you can look, okay, what's wrong with the hydroplate? And you can read about it. So now you have all the information so you can make an informed decision, all on one website. That's what they say. And then you're going to see YouTube criticisms and they'll have them there. Wouldn't it be neat if every theory did that? You know, plate tectonics, catastrophic plate tectonics. This is our theory, and this is what they say is wrong with it, all on one website. Yeah, wouldn't that be great? So get all the information and think for yourself. That's my big thing. Okay, and then they're going to have a list of answers to the objections, and these are shows. I listen to a lot of these shows driving out. They're driving back from driving out to Denver because I was doing driving back from Denver, and so I listen to these things over and over, and it's just really a good resource. Okay, and you can go into RSR and support their store. There's a whole bunch of good stuff there. Now, in the beginning, you get used copies for 120, but I'll show you how to get an electronic version for free. But again, the ones I would recommend is that CD set, and then Brian Nichols, he does a really good job explaining it. And then Jane Albright, she does a really good job of critiquing each flood model. There's 3 of them out there. And the hydroplate theory, that's out there. And there's a story behind the story. If you're interested in that, Jane Albright, that's where you would go for that. Okay, now this is how you get the 9th edition for free. You go into rsr.org/HPT and you scroll down until you see in the beginning that book. And right underneath that book, there's a button to the 9th edition. Just click on that. It's going to pop up and you can download it. And I encourage you to download it so you have it. This is golden information. And share it and look at it and read the radioactivity chapter. I've heard that's just an amazing chapter. Bob Enyart read it 3 times in 10 years. And and so get this information out there, spread it out so it can't be censored. And then again, register tomorrow. And speaking of censored, I got censored out when they did an interview at Real Science Radio when I was out there, and they put it up on YouTube and they censored it. And so they had to start a Rumble channel. Real Science Radio Rumble channel, so you can see what the YouTube didn't want out there. But anyhow, if you liked what you heard tonight, you're going to love the rest of the conference. You know, I believe we have the proper perspective of the past, and so we can make accurate predictions. And we need that proper perspective so we have the proper perception of the present, and so our focus is right in the future. And it all starts with getting a proper perception of the past. And again, here's those sites. And with that, I'll open it up to Q&A.
Are there any seismology data showing evidence of subterranean water?
Yes.
And I believe that is yes.
Yes. Yeah, that's how they figured out that there was water under Tibet. They did that subterranean stuff. I'm not sure exactly how they did it, but they did it. I think I don't know if it's the earthquake waves go through different material at different speeds.
Yeah. Fred's going to talk about that. In his presentation so tune in for that. Another thank you. Looking forward to hearing more over the coming days.
Good. Again, it's kind of like taking a sip out of a fire hydrant. There's a lot of information and it might be a little hard to digest right away, but I believe that this is the proper perspective of the past. And I think Kevin Lee's talk on Saturday will be an excellent example of 2 different views of the past and which one is accurate based on accurate predictions. And it'll be really interesting to hear his conversations.
I was looking at the prediction list you were showing. We're going to have to update. I saw a few others in that list that need to be circled in red.
Oh, good. Yeah,
they can't find Planet X by 2021. Well, 2021 is passed and then didn't find Planet X.
Right. Yeah, the copyright on that is 2019.
Should the geological column exist in Siberia with all the muck? That's actually something that I'm interested in looking into. I'm the person that's doing the limestone talk, and I've tried to research that. And it's really difficult to find information about the geology of Siberia. If anybody knows some places, I'd love to know about it.
Well, the geologic column, it doesn't exist anywhere. You know, it's a mental construct. We live in St. Cloud or we live on granite. There's no dinosaurs underneath us. No, it's just a mental construct. I mean, you go to Grand Canyon, it's missing 7 of the 12 layers of the geologic column. And there's 2 of them down at the bottom that are missing. So that's just a mental construct based on a faulty perspective of the past, blind chance and random collisions. And so, and that geologic column, it was finalized in 1879. They didn't have radiometric dating back then. It was horse and buggy technology.
I'll put myself on instead of being backstage. People can't tell who's talking. There's another one. Thank you so much. Coming across the hydroplate model has blown my mind. I look forward to hearing more.
Good, good. It blew my mind too.
Thank you very
It
much.
really did.
Birthday boy says hello. Is hydroplate theory compatible in principle with the neo-Tychonian geocentric model? Okay, who wants to answer that one?
I'll
um,
leave that to the PhDs.
I'll write that one down. We maybe if you have a really technical question like that, come at I think it's 6 o'clock on Saturday Eastern time.
Yes.
We have a whole hour of Q&A, and
Yep.
we will have a
Yep.
panel on to be able to address some technical questions like that. So if you could come with that question during that time, uh, that would be really great.
Oh, I forgot to mention people can donate too if they like what they heard.
Yep.
You give a
Um,
waiter, yeah, you give a waiter $5 for carrying food.
Another question, will be able to watch this over and miss a few parts? Yes, we're recording it and we are going to get that up as soon as possible. I'm going to post a link right on that page where you go to register, right underneath the title of this talk. I'll try to post a link there. So yes, we can. I think, let's see about Brian Nickel, how to contact him. I will, I think possibly you might be able to contact him through his YouTube channel. Brian, maybe if you're still on there, you could pop into the Q&A if you want to,
Oh yeah.
so I can see if you want to recommend people want to get in touch with you. Former Earth Science teacher here. We've reached time. Okay, I'll write down that with multiple impacts on the near side of the moon, could constructive interference go through the interior of the moon to the backside and create the largest crater on the moon? Definitely come with that one for the moon talk if you can at all. Um, yeah, we will. Okay, we got Nicole's typing an answer to that one. Hang on a second. Can you share the version 9 download information again?
Oh
Can't
yeah.
find it on RSOR. So also I should mention that we're trying to collect a lot of the resources on hydroplate.org, the website where the registration was. I'll try to post a link right there too, if I can get a link to that right on that page. And you can access on hydroplate.org. If you there's a list of videos and audio. We've tried to collect them. It's great to go to rsr.org, but like if you're traveling, if you're in the car, sometimes I find it a little difficult. If you want a simple navigation, all the audio, all the radio shows are listed right there. You just click on one, so you can keep your eyes on the road. Um, so either one is okay, but we'll try to put that link also on hydroplate.org to the. But Brian can, or yeah, Brian can show it again here.
Yeah, it's rsr.org/HPT, and just scroll down until you see the book in the beginning, and then right underneath the book there should be a button that points to the ninth edition, and you just click on the ninth edition and it'll pop up, and then you can hit a download button and then you'll have it and nobody can censor it. So that again is rsr.org/HPT. That's an amazing site, man. It's got everything hydroplate right there. It's amazing. And I think and then on the answers one, they've got the published critiques. But then again, that's the ninth edition. Hopefully, prayerfully, it'll be out this year. I've been hearing that for the last 3 or 4 years. Yeah, it's going to be out this year. And it's got a 2019 copyright on it. So hopefully this is the year. And if not, we got the electronic version. So we're just going to run with what we got. And this is easy to share with people. And this is a priceless book. I mean, the eighth edition is 270. You go, and if people want to chip in on what we're doing, if you want to donate, there's a button on that hydroplate.org. And so if the more resources we have, the bigger splash we can make. And we need to make a big splash before NASA makes another colossal blunder.
Okay, Brian, do you remember off the top of your head how much did the original Earth shrink since a lot of water and rock went into space? Was it by 3% or something? Do you happen to remember off the top of your head? Maybe someone
Oh,
else can.
that sounds right because let me see, let me get off of here. That sounds right because his first, like his early editions, he only had it was 10 kilometers deep and then it was 10 miles deep because he started adding the trans-Neptune objects and the meteors. First, he just allowed, I think he just allowed for the sediment on the Earth. the Earth sediment. And then I think he allowed for like the comets and the asteroids. And now he's allowing for the trans-Neptune objects. And I think it might be 3%. And that would cause the Earth
Something
to,
about.
yeah, that would cause the Earth to spin faster. And so that would change. And it seems like there's evidence that there was a 360-day year. And that would cause the Earth to spin faster. So now it's 360, what, 4.25 or 3 and 5 1/4.
Okay. Real quick
So are you guys
here,
able to?
mentioned Tim Clary's work and his book Carved in Stone, which is critical of hydroplate theory.
Yeah.
For instance, he says the evidence for the ancient lakes like Hopi Lake and the other lake is poor. What is your response to this criticism?
Well,
Is
that's
there, is that's been handled somewhere on
Oh yeah,
rsr.org? Okay.
yeah. That's been handled. The reason there's no evidence for a shoreline there is because it wasn't there that long, and it was very unstable with all that block faulting. You might have shore here today, and then another block comes up, so now the shore is somewhere else. So it wasn't there long enough to make a shoreline, and it doesn't have lake sediment there because it all drained out with it was a violent draining, and then all the shores were all full of water too, so that drained out too. And so that took the lake sediment out of there, and there may not have been very much lake sediment to begin with, because it may have only been there 100 years, 200 years. It just had to be there
Mm.
long enough for the Kaibab limestone to harden. And so, yeah, there's no evidence for that. But if you take a satellite picture of that area, you can see the lake beds. It's a distinct color. That's an orangish color. It's very different than the surroundings. And so you got Grand Lake and you got Hopi Lake. And that's a good question, though. That's a really
Yeah.
good question.
Okay. So to know more, go to rsr.org and use the search box to find
Yeah, or slash answers.
slash answers, and it should be listed there.
Yeah,
Okay.
there might be an interview. Brian Nickel probably did something
Um,
on that.
are there any predictions like such a unique chemistry that have been or can be made about the water that will be found on the moon or in asteroids that would indicate that it came from Earth?
Well, I would think that that like the cubonite and let's see, the cubonite and the clays and the limestones, that would be a strong indicator of liquid water. And where do you find liquid water? You find it on Earth. And what Walt Brown has done, and this is kind of I'm not really addressing the water question, but he said that the imperial sand dunes in California, when they analyze that, the sand isotopes, they're going to find that it came from Grand Canyon. And so that's a prediction. I'm not sure if it's one of the listed, but as
Okay.
far as the water compensation, the water coming from the earth, I don't know where else it would come from.
So analysis of the sand, that would be something that a person, if we wanted boots on the ground for research to find that out, somebody could get some samples and test that.
Right.
That would be
Right.
something that someone could do.
Yep.
Okay, so we don't know if there's any exact predictions about the water on the moon, but it might be good to make some.
Yeah.
Um, heard from
Oh, there is
Bob.
a prediction too. He said that you might find radioactivity on the surface of the moon, but you won't find it on the subsurface, because he thinks radioactivity is a result of the flood, and it's not created material. It's a result of the flood, because God said it was very good. And would it be very good to have a material that can cause birth defects or cancer?
Um, let's see. I heard from Bob that the whoops, it slipped up there. Hang on a second. The Oumuamua asteroid posed problems for hydroplate theory. Any
Oh,
progress on possible resolutions for whatever that problem might be on Oumuamua asteroid?
yeah, I think is that the asteroid or is that the comet? I know
Uh,
I don't know how an asteroid would be a problem, but a comet would be a problem, because if it's a hyperbaric, if it's a comet that they say came from outside the solar system, that would be a problem
I
for
think there
this
was one
theory.
on the hyperbaric orbit. We can definitely deal with that. That would be another one to deal with during the comment
Yeah, because
session. Definitely.
because that's actually, I think that's even listed on rsr.answers, or I think it's on one of those two websites. I think
Okay.
I remember seeing it. And Bob I'm not sure if he had some sort of explanation for it or not, but that's a really good question. That's a really good question.
Okay. Here's
And
one about when the ninth edition will be printed. And I actually have the most recent update on that, possibly. Yes, the ninth edition is on the way. It is in the works. There's
Good,
no exact time for when the printed copies will be available, but things are moving forward on that. So
good,
hang in there.
good,
And I
good.
mean, all of our websites will have information as soon as it is. We will let you know.
Right,
But it is in the works.
right. Because
Um,
the ninth edition is out there. The longer it takes them, the less they're going to sell.
so okay. Let's see. Are granite rock piles and mountains a good proof, whoops, of yeah, sliding up here. Are good proof of rapid mountain formation? Are granite rock piles and mountains a good proof of rapid mountain formation? Do we have
Granite, granite
any
rock piles.
uh
Yeah, that might be a good question for Brian Nickel if he wants to pop in, because I thought most of the mountains were sedimentary rock. I'd be interested in to see where they see granite
okay.
rock piles in mountains. And if it was granite rock piles, I would say they got crushed during the compression event. But I'm just shooting from the hip here. I don't have any data to back any of this
Okay.
up.
Okay. So Brian, I'm reading your things. Brian, how are you back coming on live to answer some of these? Yay or nay? I'm scrolling through the questions as fast as I can. Pop them in here.
I
Um,
tell you, Brian Nickel, his YouTube videos are
okay.
game
All right.
changers.
Here we go. Hang us on a second. Um,
Hey, Brian Nichols on. Good. He's a rock star here.
okay.
I
I
encourage
even, if
everybody to
you accept it, you can pop on the screen if you'd like or not, either one.
subscribe to
Um,
his YouTube channel. It is excellent.
Can you hear me?
Yes.
Okay. I guess I'm not seeing the screen part of it, but
yeah, hang on a second. Let me,
I mean, I don't care if I'm
no,
visible on
um,
This will be your big break.
screen.
Are
what
you
I
working
need,
on
all I
anything
need
new,
to
Brian?
do,
Are you
Yeah.
working on any more videos, Brian?
Yeah, I have one I've been working on for a few years, and then I have a couple of others that are in my head right now.
I can't wait. Can't wait. Your stuff is gold. It really is so well done.
okay, if you want to appear, if you accept the panelist thing, then I can put you on a,
Are there any questions
yeah.
or
Okay, so that one for Brian. Let's see. Is this correct that the Great Denudation and all material moved from Grand Canyon ended up in Gulf of California? If so, is this the Salton Sea? Is the Salton Sea a part of this?
Well, no, it didn't all end up in the Gulf of California. Walt Brown says you can see where that sediment went as you're driving east west in that area as you're going towards the Colorado River. And he says when you go over a riverbank, just slow down and look down the riverbank. He says for 1 or 200 miles on either side of it, you're going to see boulders in sand. And boulders in sand means that the boulders means that it was a rapid flow, and the sand means it stopped suddenly. So there's a floodplain that goes, I'm not sure how far on either side of that Colorado River. That's where a lot of it ended up. But then again, a lot of it did end up in the Gulf of California. And it's not at the Delta because it came out with so much force, it pushed the ocean back. And so a lot of that sediment went halfway out there at least. And Brian Nickel does a really good job of comparing the different deltas on his videos. Is that close, Brian? Maybe I should have let you answer that.
The transition to video had a little bit of a time gap, I think, when I came on, so I only heard half that question. It was where did all the sediment from the
It
Grand
Okay,
was,
yeah, I
it
Canyon?
can
was,
read. There's two questions on the table. Are granite rock piles in mountains a good proof of rapid mountain formation? That's one. Do you want to comment on that, or that's just
I mean, I'd like to understand a little bit more about maybe specifically what
okay?
granite
What all the
referring
rock
to,
piles are?
but
Okay,
I'll say when you look at the mountains from a small scale to a large macro scale, like at the satellite level, looking at mountains, you can tell that compression has happened in an east to west direction, certainly for the Americas. And so all kinds of different things piled up during that compression event, what the hydroplate theory calls a compression event. So whenever kind of broad yet vague questions like that are asked, I tend to want to know a little bit more specifics, but in general, there's a great deal of compression in the east to west direction that I think speaks for the mechanics of the hydroplate theory.
Okay. Kind of a related question about is Dr. Clary shows 6 megasequences making the sedimentation. Could water hammers of the edges of the crust slamming into the mantle, cutting off the fountains, have created the megasequences?
Ooh, good question.
I
Really good
don't
question.
know that the water hammers necessarily would have been the mechanism to explain a mega sequence. A mega sequence is a term that has been applied to the geologic column, certain sequences of the geologic column that they seem to repeat with certain types of materials that they've clustered into mega sequences. How that specifically relates to the varying conditions of flow out of the rupture during the 40 days of the rupturing event. I don't know that we can tie that specifically to any specific mechanism.
Is it compatible? The mega sequences, they don't pose a problem necessarily for hydroplate theory, do they?
Well, no, just because somebody makes up a term called a mega sequence, I don't think that poses a problem. What these are layers of materials that are continent wide, and what those speak to is some sort of a global spreading mechanism.
Mm-hmm.
And I think global tide, along with the fact that, with the idea from hydroplate theory that these materials were ejected high up into the high atmosphere. Some of them came back down. Some of them left forever and never returned. And so those were getting spread all over the surface of Earth as they came back down over time. So that combined with liquefaction, I think, produced those layers.
Okay, this is the question you only heard part of. Is this correct? The Great Denudation and all material moved from the Grand Canyon ended up in the Gulf of California. If so, is this a Salton Sea? Is the Salton Sea a part of this?
I have to look up and be familiar with what the Salton Sea is. The
Okay.
northern half of the Gulf of California is extremely flat and it is loaded with sediment. When tide goes out in the northern Gulf, it's very shallow all along there. And that's because that material that fills the upper half of the Gulf of California is all sedimentary material. And that material isn't a delta, but it ran out into the Gulf of California probably due to 2 events. First would just be the runoff that came off of the continents as they lifted up out of the waters during the compression event. And then as water ran off the continent, water and sediment, about half of that fills the northern half of the Gulf of California probably just came from the initial runoff. And then centuries later, when the Grand Canyon was formed, the remainder of that material flooded in on top of that.
Okay. This is a follow-up on the moon asteroid water question regarding unique chemistry. For example, percentage of heavy water in a moon/asteroid sample as compared to Earth. Or would we expect the structure of the water to have changed as a result of heating, cooling, Earth's radiation, solar radiation, etc.?
That's a good question. That's a real good
Yeah,
question.
Does
I'm
Walt
not
make
sure
any
about.
predictions about does he make any predictions about the water we might find on the moon, what its chemistry would be? We'll have to ask
No, I
Doug
mean,
if he
I guess
knows.
I'm not quite sure what they're asking the chemistry would be. I mean, water.
All right. Well, Doug, if
Um,
you're listening, you want to chime in on that one.
I would expect that water that hit the moon would be similar to the water that you find in asteroids and comets. So there should be a
Sure.
shared um, percentage of, say, deuterium, some similar higher elevated uh, types of deuterium richness in the water that is found on the moon, because hydroplate theory would maintain that water that struck the moon would be the same from the same source as the water that eventually became comets and that became part of comets, and the water that became part of asteroids. That water is alleged to all be from the same source, so we would expect similar uh, concentrations of deuterium.
Okay. Well, Doug, off stage, I just got a note. Doug McBurney would like to answer this question. Do you think there were any sources of water from outer space, not just from the fountains of the great deep? Doug, do you want to field that one? You can, Nicole, you can unmute.
If I can you hear me?
Yep,
Yes.
I can. Yes.
So the answer to the first question is no. We don't believe that there were sources of water from outer space. It all came from the Earth. And then as far as the previous question regarding the water on the moon, so there have been these water beads, these lunar glass beads containing water inclusions that have deuterium levels that are similar to that found in the carbonaceous chondrites in meteors. And so that also supports hydroplate theory.
Okay.
And then I was on the CRS Net Creation Research Society open forum today, discussing the hydroplate theory with a number of people. And I spent a good part of the day linking to passages in the 9th edition, simply correcting misinterpretations and misstatements about the hydroplate theory. And one of them had to do with water. Basically, they said, well, Walt Brown predicts that the water came from the Earth, and so it'll be the same as the water in the ocean. But that's not true, because the hydroplate theory asserts that there was a certain level of nuclear energy that was produced during the breaking up of the fountains of the Great Deep. And so the hydroplate theory actually predicts that there would be this heavy hydrogen difference in the water in our oceans and the water that we find, whether it's on the moon or in asteroids.
Okay.
So hopefully that answers.
Thank you. I should put in a plug here. It just crossed my mind. I was talking with Brian Lauer earlier. We, for anybody that's interested in discussing particular topics, I'd like to have some future events a couple of times a year where we go into depth. For example, here's one question here. Someone says, where was it? Wondering about Iceland. What happened? Where did Iceland come from? I have stared at my globe and thought about Iceland more hours than I care to admit. If anybody has some ideas, wants to do a think tank about Iceland, yeah, why is it the only, boy, I would like to hear what some other people think about Iceland. So maybe we can have an Iceland night. I'd love to have some, yeah, there's a lot of interesting features that it would be interesting to come up with a hydroplate explanation. So, yeah, I'll make a note of that. Maybe we can, uh, have a meeting of minds on that in the future.
Yeah, they got
Um,
Xerxes. They got Xerxes. That's an island off of Iceland. It erupted it started showing in the 60s, like 1963. And it's got a lot of really mature features on it that are supposed to take tens of thousands of years to get, if even more. And it's a really conundrum for
yeah.
somebody who believes in blind chance and random collisions.
Okay. We'll just do a couple more. So this one might be a good one to pose to Rob Brown, our resident astrophysicist. How could subterranean water ejected from the Earth travel all the way to Mars where it caused significant erosion? So I don't know if you want to.
Well, there was tremendous pressure on in the fountains of the Great Deep, the subterranean water chamber. Walt Brown says there was 372,000 pounds per square inch there. And so it erupted with tremendous force. So a lot of that just kept on going. It got out of it's going over 7 miles per second, I believe, and it broke through our atmosphere and our gravitational pull. And some was even going faster than that. And it just kept on going. And then Mars would be the gravitational source where that water would end up.
Okay. So here's a question again on what happened to the Earth. We said 3% about of the Earth's mass gas was ejected. And then Brian, I saw your note, 180 miles. So you want to add the radius or the circumference, Shank? I'm not going to
So
scroll back.
yeah, based on the 3 to 5%. So, and that 3 to 5% just comes from the estimation of mostly having to do with how many TNOs might be out in the Kuiper Belt. And so depending on what that number actually is, then that'll depend on how much percentage of Earth's mass is estimated to have been lost. That combined with another very large factor is the melting of the inner Earth. Once the Atlantic ocean floor began to rise, then the center of Earth essentially went through a shearing process that sort of extruded material through the center of Earth and pulled the Pacific plate down as the Atlantic floor rose. And so that melting caused the magma, once it changed from solidified mantle material to magma, if it was under the crossover depth, which is only about 225 or 220 miles down, anything underneath the crossover depth that turned to a liquid was compressed to about 50% of its original volume. And so that is the major thing that caused the 180-mile estimated shrinkage of Earth. And that's another thing that adds to the compressive features that we see on Earth. Not all mountains were formed just due to the compression event. There are many mountain chains that probably formed after the compression event due to the shrinking of Earth, and that essentially caused the skin of Earth to have to compress in a lot of places. And so
Okay.
it's like when an apple shrinks just due to loss of water that you leave out too long, its skin, which used to be tight, becomes wrinkled due to compression because it's losing volume. Same concept with Earth.
That's what people believe before plate tectonics. My understanding was that was the leading theory before that continental drift. That's the shrinking apple, they called it.
Yeah. Well, this would be the mechanism that actually would support the features that you see on Earth that are compressed. I mean, whoever came up with the shrinking apple idea first, they were doing it because they saw things that made them think that must be what's happening. I think hydroplate answers the mechanism that
they were correct then, what they were seeing. They were doing a correct observation.
Well, possibly. I mean, I don't know every, I don't know specifically what observations they were making, but certainly a lot of the features on Earth are compressive features. And I think hydroplate has a mechanism that shows why those compress.
Okay, Rob Brown is backstage now. I'm
Can
trying
you
to
hear
find
me?
the questions.
Yes.
Yeah, was it the question about how could subterranean water ejected from the Earth travel all the way to Mars?
Yes.
There's a question about that. Is that the one you wanted to address?
Yes, and I'm going to talk about that Saturday, but real quickly, there are three forces I think that would have propelled the rock and water away from the sun. One is solar pressure. Just the photons coming from the sun create a little bit of pressure and push things away. And satellites are built today, some are, with solar sails. It doesn't create a lot of force, but it's constant. There's another force, just if it's often referred to as the radiometer effect. It has, if anyone's ever seen a radiometer, it's a little fins that spin in a bulb due to the difference in heat on one side of the fin compared to the opposite side, black versus white. And that would, because one side of the TNO would be getting hot more, the water particles would bounce off of that with more momentum and also push it away. And then there's something else called the Yarkovsky effect, which has been documented as a force that moves satellites away from the sun. I think all of those would have been much greater than we see today if you had, maybe thousands of miles in diameter of these swarms of rock and debris leaving the Earth together. And I'll talk about that later. And someone asked a question earlier too about the, I can't pronounce the name, but the asteroid, it's got a Hawaiian name.
That Oumuamua.
Yeah.
Yeah, the reason it's viewed as creating a problem for the hydroplate theory is it has been observed to be on a hyperbolic orbit, meaning it's going to come past the sun one time and then it'll be gone. But the hydroplate theory predicts that you wouldn't see anything coming into the solar system on a hyperbolic orbit. And this was not observed outside the solar system. The first time it was observed, it was in the solar system. And so it could have received a gravitational boost from a giant planet like Neptune, and it's not that big of an asteroid. But if a close pass by a big planet or just a larger object, even if it's something like Pluto or Sedna, a giant TNO, could change its velocity and send it on a hyperbolic orbit. So the hydroplate theory predicts you'd never see something coming into the solar system on a hyperbolic orbit. But this is on a hyperbolic orbit, but it's leaving, and it wasn't observed before it came into the solar system. Now, I think that's kind of a tough prediction because I don't think we're ever going to observe something before it gets into the solar system. But just because it's on a hyperbolic orbit doesn't mean it came from outside. It was never orbiting the sun before. It could have been on a highly elliptical orbit. And then as it's coming back into the solar system on this elliptical orbit, and I believe it was launched from the Earth during the eruption event. And as it was coming back in on this elliptical orbit, it got a little bit more of a boost as it came by another giant object, and that gave it a gravitational acceleration that sped its velocity up, and now it's on a hyperbolic orbit.
Okay. Do you know anything about, there's another NASA question. I think maybe this is the last one here. NASA has found subsurface water on 17 objects in our solar system. They thought that was possible. That was maybe a news item. Have you heard anything about subsurface water on 17 objects?
I've heard about it on some. I don't know if I've heard about it on all 17, but I've heard about it on some, yes.
Okay. Is there any comment? I don't know what that means, subsurface. What kind of objects? A few examples.
Some of the smaller moons around Jupiter have been discovered having subsurface water. But I think it's consistent with the hydroplate theory. They're smaller, they're very small moons, and they probably have water on them.
Enceladus as well.
I'm sorry?
Enceladus.
Enceladus.
Yes.
If I'm pronouncing that right.
And someone also asked a question about what kind of water would you predict on the moon? The hydroplate theory did make a prediction that the erosion channels that were seen on Mars's surface you'd find salt along those erosion channels, because the hydroplate theory predicted that it would be salt water that caused that erosion, and the water would have evaporated, but you'd still find salt. And when after that prediction was made, Mars rover discovered that there is salt content around those erosion channels.
Okay, so that's another confirmed prediction we can circle. That was on. Okay. I think that's subterranean. This is just a comment regarding the earth roll. I find it intriguing. The Bible says that people went east to Babel, yet Babel is southeast of Ararat. This would put the pre-flood North Pole to approximately in Siberia. So that's just an interesting comment we could follow up on, maybe talk more about it in the Q&A session. Okay, I hope I've there's a few links here I can follow up on afterwards. I can't open them right now, but so last chance here, if anybody has a question to pop in, we're going to wrap up here in a few minutes. It's getting late on the East Coast, and then we'll just go back to Spotlight. Let Brian Lauer close us out. Do you want to close us out, Brian Lauer?
In prayer, or are we?
Yeah, or
just however. Okay, well,
yeah,
I just thank everybody for.
Yeah,
I do thank everybody for zooming in with us tonight. And I do believe that the hydroplate is the proper perspective of the past. And we need to put pressure on, and when people are using blind chance and random collisions of atoms, they are not doing, that's the wrong perspective of the past. And I encourage you to, go into RSR and Brian Nichols' site and learn more about this hydroplate theory and talk to people about it. And also, if you feel inclined to donate so that we can make a bigger splash in the future, because we're the little guy, we're Grant throwing strikes, and they're the big guys pitching into the dugout. And so we need more of us so that we can get rid of this paradigm that's holding science back. So again, and if there's anything I can do for anybody out there, man, I'll go anywhere to get this message out there. And churches, schools, colleges, wherever. And I've got a website called solidifyyourfaith.weebly.com. That's WEEBLY. And so if anybody wants, or my email is hotmail, solidifyyourfaith@hotmail.com. That's solidifyyourfaith@hotmail.com. And we'll do what we can to get the truth out there, because it needs to get out there. And all this points to a creator, and that creator sent his son to die for our sins. And that's the most important message. And I believe that's why there's so much resistance to this message.